Hello everyone, very good evening to all of you. On your request, I have come up with this very amazing session on 12th chemistry boards exam, which is gonna to happen on 27th of January. I guess this is the perfect day. We'll be solving one paper with all of you, and it's a most guess-based question. So you all know that I'm a teacher of IIT in advanced, and with the team of Unacademy, all our teachers and experts have sat together with me and formed this paper. So this is the most expected paper. So many questions are very much repeated in the previous years, and also on the basis of the pattern that has been asked this year 2025 examination, on that I have come up with some of the very important questions. So let's start the session very soon. Please everyone join fast and keep liking the session, because that is what a teacher needs from your side. Okay, that's a typical feedback we have. This is most expected questions of chemistry. Meet me, my name is Sanjay Arya. I have completed my graduation from IIT in Dhanbad, and then I've been teaching for more than 10 years. You can scan the code and can join me and can ask me about your doubts, and academic and non-academic doubts can be solved over here on my Instagram, and this is my Telegram. You can click on this link and get through it. Thank you guys, I'm well for asking. So this is the pattern on which questions have come from. Like on this very much year 2025, 2024, 2025, these questions have been asked. This is the pattern. Every single paper contains 33 questions. Out of these 33 questions, section A contain 16. These are 16 multiple choice questions which are carrying 1 mark. In these 16 questions, guys, let me again redefine this part. 12 are single choice questions and the 4 are the assertion reason questions. And the students have submitted me the feedback that they are not able to crack assertion reason because this is a new concept to them. Those who are very well doing the NEET and JEE main preparations, they know very well about assertion reason question, but the students who are directly facing these questions are not very easy to crack. But anyways, I have plenty of such questions. Okay, so then we have section 2 contain 5 short answer question carrying 2 mark. Section 3 comes with 7 short answer questions of carrying 3 mark. Section D contains 2 is case based question. I have come up with 3 or 4 case based question. So those individual questions contain 4 questions in each segment in each case. So we have plenty of questions to solve on that. And then finally we'll be coming to the most important part, the most weightage carrying part of this entire session, that is your 5 marks question containing these are 3 questions actually in these 33. So guys, let's start it. Do not use the log tables and calculators in your examination, and don't even take these kind of unnecessary stationaries with you. Okay, let's start the first round of today's session. I would expect people to solve the questions with me as well, and please try to submit your answers in the comment section itself. Okay. So that's why we are having right now the 1 mark question over here to make you comfortable in it. That's the first question, everyone. Let's start doing the first question. The tip is, okay, you need a tip. The tip is that do not waste your time on these questions which are very simple and very straightforward question. Only need to type the answer. Okay, you got to write only the option. Do not even waste your time on writing what option. Unnecessarily don't write like option B, then 2-bromo, 3-methyl. No, don't need to write that. Simply solve them as quick as possible so that you can invest your time more and more into the higher weightage questions. Let's see, the first question came in 2020, 2018, 2017, most repeated question, and we have to name this compound. So how can we name it? This is C2H5. So these are like 2 compounds are there, 2 carbon atoms are there. The whole chain will be of 1, 2. I'll start it from here because substituent is coming bromide. 1, 2, 3 and 4. So there are like 4 carbon atoms in the main chain. How can we name this compound? We have 3-methyl and 2-bromo. So we'll make it 2-bromo. No, yeah, it's just 1-bromo. And on second carbon, we are having methyl group, 2-methyl. And meth, eth, prop, but. Butane, simply butane. No unsaturation, no double bond and triple bond is there. This is the name. So 1-bromo, 2-methyl butane. Where can you find this answer? I think C is the correct answer. Now let's look at the correct answer. C. Very good, J Advanced, very good. Keep it up, guys. Keep it up. Everybody, please join the session. Everyone, please show me some energy. Keep on liking the session. I have plenty of questions here. Right after doing this session, you will not require any further exercise, any further practicing. Do attend this video, do attend this lecture. You will be getting easily very good 60 plus marks in your chemistry examination that are to happen on 27th of January. Let's come to the next question. There is the next question. We have the nucleic acids are the polymer of. Okay, we have two parts here. One of them is nucleoside, another one is nucleotide. They are polymers of nucleotide. Nucleotide is the monomer of the nucleic acid. How? Let's look at this. This is the correct explanation, that a nucleotide contains three important things: nitrogenous base, pentose, and the phosphate group over here. And this is the monomer. Its polymer is actually the nucleic acid. And also that part is called as nucleoside, which contains only nitrogenous base and the pentose sugar, not the phosphate group. This question came in 2021, 2019, and 2015. Correct, guys? D is correct answer. Let's have the another question. Oxidation state of cobalt. Well, usually cobalt in its octahedral complexes, where the coordination number is 6, usually has oxidation state of +3. I'm just guessing it, but again you can try it also. How? Sir, let's guess. Cobalt has a oxidation state. En has 0 charge on it, so 3 multiplied by 0 plus 3 times of sulfate ion will be equals to, how much is the overall charge given over here? Well, I think there is something missing in this question. Okay, this is double. So let me just rewrite this again. This portion containing x and 3 times of 0 charge multiplied by 2, and this will give you 2x minus 6 equals to 0. X will come up as +3. Even this question was not if I was not aware about the question, or I was just simply known to have a octahedral complex of cobalt, I would go for +3, because if 99.99% times this will be +3 only. B is the correct answer. 2019. This question was asked in 2019, and this will be seen in your coming exam as well. Okay, let's see the another question. We have another question asked in 2018, and it's a hard question, means it's a high order thinking question, not a very easy question. Which of the following is the strongest oxidizing agent? What do you think? Which can be the strongest oxidizing agent? Do you know what is the meaning of an oxidizing agent? Oxidizing agent undergoes self-reduction. Oxidizing agent undergoes self-reduction. So self-reduction will try to absorb an electron. Let's look at manganese, guys. Manganese has an atomic number of 25. And it's with 3 positive, has an electronic configuration of argon 4s0 and 3d4. Let us suppose if I give it 1 electron. Let's say if I give it 1 electron, it will acquire a configuration of argon 4s0 3d5, which is a half-filled d subshell stable configuration. Half-filled d subshell stable configuration. And I think that's why it should be the correct answer. Can I take another? Okay, one more is there. Let me see. I think this is the only correct answer. Let's not waste the time, guys. Just learn it and move forward. J Advance, you have submitted me the correct answer, buddy. Very well. You are going good, and I hope you do the same thing. It's the same energy you show in your exam, and the same kind of feedback you give in your exam also. Crack the exam, man. Crack the exam. Let's see, another question came in 2018. Which of the following is the strongest base in aqueous solution? So guys, always remember this part, man. If it is given with the let's say if the methyl is given to you, so let's say if the methyl substituted amine is there, so in that case the order becomes 2130. And if we are having ethyl group or other groups are there in the connected with this nitrogen, then in that way the order becomes 2310. Now you check out, everywhere you will be getting secondary as the most basic base over here. Now can you identify a secondary amine here? I think A is the correct answer. Can I see A answer? Yes, G Advance has submitted with the correct answer. A is the perfect answer. Very well done, everybody, very well done. Let's see the another question. We have another question that came in 2020, 2017, 2014. These examples are very much important, guys, because these can be asked anywhere. And again, why am I bringing this session to all of you? Because it doesn't even require to practice anymore. If you attend my lecture and if you do all the questions very well, practicing by your own, you will not require a single question apart from these to solve up with. You will be highly confident. But again, this is my guess-based questions only. Probably most of the question will be seen in your coming exam also. But you must try your NCERT first of all, and you have to finish it as well. Which of the following reaction will be the fastest under the identical condition? I don't know what's the condition. Okay. Ethanol with so many acids. Okay. What is this reaction, by the way? This reaction is it's an SN1 reaction, nucleophilic substitution reaction, and all the nucleophilic reactions, basically the rate of reaction directly proportional to the acidic strength of the acid which we are using. And the acidic strength is, we all know, HI, HCl, HI, HBr, HCl, and then HF. So the most of this reaction will be taking place at fastest rate will be with HI. A is the correct answer. Some of them are writing D also, but Preetha, you must know that HF is a weak acid. HF is a weak acid and doesn't dissociate easily and will not provide H positive ion easily. So let me even reveal you how does this reaction takes place, guys. I know this is a bit apart from the question, but again let me reveal you how does it work. We have CH3, CH2OH. We have to first give it to H positive. Who will give us the fastest H positive? The strongest acid, which is H positive and I negative. Now I negative will be working as a nucleophile, H positive is working as a electrophile. O with a lone pair will attack over here and will form a group like OH2 positive. In the next step, iodine comes, attack over here, and this will be separated out, and that's why we say that the rate of reaction is highest with HI. Can we have the answer, please? Okay, A is perfect, guys. A is perfect. Rukmani and G Advanced, you people have submitted with the correct answer. Keep it up, guys. Keep it up. Let's bring the another question. We have the another question that out of the following, which one of them will be most reactive towards the nucleophilic substitution reaction? What do you think? Which one of them will give you the most extent of nucleophilic substitution reaction? This is called as vinyl group. Why? Because doubly bonded carbon attached with the carbon, chlorine, this will give you a lone pair like this and poses a double bond character. Here it is a double bond character. And the same thing will be seen even in benzyl also. Benzyl, not benzyl, this is called as chlorobenzene. In the chlorobenzene also you will feel the same double bond character. So these two are not the correct answer. Even this is not correct. Even this is not correct because this is in the resonance and there is a double bond character over there. This is the example which doesn't have any conjugation as such. It will be broken down easily and this reaction will proceed through faster with SN2 reaction. So I think D is the correct answer. I think D is the correct answer. A few people have submitted me D answer. Very good, guys. But I want more people to join. I want more people to spread this, that we have come up with this session. Very amazing session. Your IITian teacher has come up with board's question in order to help you to get good marks in examination. Believe me, guys, even at my time of the exam, I couldn't have made it to that much level because by that time we didn't have teachers like me coming to me directly through YouTube and like teaching you about how questions have been asked, how to attempt the question like that. These questions, what you are seeing right now on the boards are the single choice question. You not need to waste your time on writing what options are there. Just simply put the option number A, B, C, D like that and just finish it in just quickly, just 15 minutes. And let's move forward to the next segment. Another question is here. Which of the following ligand forms a chelate complex? I love just chill. Chill means this is gonna to form a circular ring, cyclic ring, and with the complex metal ion. So can you check out of these water cyanide? C2O4. It should be polydentate. Always remember, chelate ligand should be polydentate. Even a bidentate ligand is fine. So this is what a correct answer is. This is M positive. This is the structure of oxalate ion. So that is how it is forming a chelate ring. Correct answer should be C. Oh, we have now toppers in the house. Rukmani and G Advanced have submitted me the correct answer. Good going, guys. Good going. Keep going like this and show the best in your exam also and make your teacher proud. Okay, make your teacher feel proud. That was a question came in 2020. We have another question that came in 2020, and the question is simple and says that the formula of this compound tetraamine chlorido. So there is one chlorido, okay? There is one chlorido and nitro N. Since it is been given for nitro N, this will be cancelled out because this is nitro O. This is nitro N, but two chlorine are there. It is not correct one, and there is no chloride inside it. I think C is the correct answer. So the method which I am right now using is called as option elimination method. The method that I am right now giving you is called as an option elimination method, that the option that fits to your requirement will be the correct answer, and you can remove the rest of other one, okay? That's it. Now I'll take you to the next question of the same league. We have a question came in 2022, a question that came in 2022, exactly 2 or 3 years back. Oh my god, this question is very simple. This is a naming reaction. I hope you all know about this reaction. This reaction, if only benzene could have been used, is called as Wittig reaction. Fittig. If only Rx is used there and RR is the product, is called as Wurth reaction. You add both of them, it becomes Wurth-Fittig reaction. B is the correct answer. Can I see the correct answer, guys? Rukmani, J Advance, you people are rocking. We have Pritha with us. Pritha has also submitted me the correct answer. Even Shrivansh J has submitted me the correct answer, B. Good going, guys, good going. I want you people to show me the same josh and the energy what right now I am having, okay? Even I'm feeling the equal excitement. You have an examination on 27th and it's been 2 days right now left. You please go through the whole paper once again. You can download this paper on our Telegram channel. It will be available. Go and join our Telegram channel and please subscribe to our channel so that you will be keep on updated coming for the upcoming videos, okay? And that's it. And don't forget to like the session, okay? Because I have done a lot of hard work. I know last night I couldn't sleep properly because I was making this whole paper for you people only. I was trying to grasp all the questions which are repeatedly asked in the examination, and they have that potential to be appeared in your coming examination. So please, guys, this is what I deserve only. I deserve likes only. Just keep on liking the session and just enjoy the session. We have another question. In which of the following pair of the oxo metal ion, the oxidation state of the central atom is the equal to the group number also? Somebody submitted me B as the answer, but I think B is not the correct answer, or might be, no idea as such. Okay, take over here. So group 3, group 4, group 5, group C, group 7, and that's how it works. Group 3 start with scandium, titanium, vanadium, chromium, manganese, ferrum, cobalt, nickel, copper, zinc. Okay, and I think I have covered all the elements given over here. So what we think that if it's for chromium, group 6 should be the oxidation state. For manganese it should be 7. Vanadium it should be 5 oxidation state. Now let me check whether it is correct or not. If I look at option number A, manganese, in its permanganate ion, X plus 4 times of minus 2 is equals to minus 1, X comes up as positive 7. And the another is Cr2O7 2 minus, called as dichromate ion, 2x plus 7 times of minus 2 is equals to minus 2, X comes up as positive 6. If X is positive 6, X is positive 7 here. I think this is the correct answer. A is correct, but okay, there could be multiple option also, as I have seen it already. I'll take you to option number C also. C, we have vanadium, VO2 positive. So X plus 2 times of minus 2 is equals to positive 1. X comes up as positive 5. Is it correct? Yes, it is also correct. And for the same, we have chromate ion. We have chromate ion CrO4 minus 2 minus, that is equals to X plus 4 times of minus 2 is equals to minus 2. And that's why X comes up as positive 6. I think both of the options are correct. Both of the options are correct. A also, C also. A and C both are correct, guys. Both of the options are correct, okay? Okay. Now let me take you to the another question from here. We have the next question. The single choice question are on. We have the next question, everyone. Next question says that for the given reaction 2A plus B is giving you C plus D, the rate constant is given to you. This, what is the order of reaction? In these kind of reactions, in these kind of questions, please look at this question. In these kind of questions, the reaction is not important. The reaction is not important because the reaction could be a complex reaction which is happening or which is going to occur into several steps. So we cannot identify the order of reaction directly, but the order is determined using the unit. Actually the order is mole liter inverse raised to power 1 minus n, and then comes second inverse. This is the order of the rate constant is this, okay. Anyways, let me see what I'm trying to do. Rate is equals to K into concentration, which is mole liter inverse raised to the power n. So this is also mole liter inverse and second inverse. So K will become, so this is the unit of K. The unit of K is this. So what should be the value of n here? So n, in order to make this thing equals to second inverse, this value should be 0. So 1 minus n is 0, n comes up as 1. It's a first order reaction. A is the correct answer. A is the correct answer, guys. Huh? Come on, everyone. Come on, show me some Josh, everyone. Keep on liking the session and also attempt the question in the chat box itself in the comment section, so that even I can know who is doing it right, who is not doing it right, and I can correct you at any point of time. Just ask me the question, I'll correct you at that point of time only, okay? And don't just get fear, guys. I am one of you only. I was the one who was appearing in these kind of exam exactly 10 to 15 years back. So I am the one who is right now traveling the same, like you people are right now traveling the same path that I have traveled a few years back. Let's come back to the topic. And that was a good question we had. Now we have another question, and see, these questions are highly repeated question. So believe me or not, these kind of question will be appearing in your 27th of January, 27th of March of this coming month. Consider the following figure and mark the correct option. Now, can you tell me the correct answer, guys? What do you think? So, do you know what is the meaning of energy EA forward? This energy. Arey yaar. Arey yaar. Guys, this is the activation energy forward, and this amount of energy, okay, that you see over here, and from backward, if we are going, this is the amount of energy called as EA backward. So what do you think, which one is more? So activation energy for the forward direction is E1 plus 2, yes, but the energy of product is less stable. So you see that energy, who is having higher amount of energy here? That's our energy of product is greater than energy of reactant. Means this is the one with the less amount of potential energy will be more stable, and this one will be less stable because it is having higher energy. So products are less stable than reactant. I think A is correct option. What do you think? A is perfect. A is the correct answer. Can I see who has submitted me the correct answer? It's an endothermic process. Preetha is saying correct. Not so many students have submitted me the correct answer, but yes, those who have submitted me the correct answer, it's correct. The answer will be A only. Sir, while you're sewing fastly, I'm getting scared. Don't be scared, man. Don't be scared, because we are JEE people. We are the people who are gonna to appear in the JEE and gonna to crack this toughest exam of JEE Advanced as well. And right now, what you are seeing, what you are watching to me, I am also an IITian. So I know that how these questions have been coming from past few years, and we can solve them as fast as possible, okay? I will not waste your time. I'll basically secure your time so that right after this session, you can download the PDF and can try all the questions by once by your own. And that will going to help you for sure in your coming exam. Let's see the another question now. We have another question. Okay, look at the question first and then try to decide how to do this question. In the cold conditions of aniline, okay, these kind of conditions, these kind of reactions are going to happen at 0 to 5 degrees Celsius, because diazo compound is not stable at the higher temperatures. So how does this reaction take place? Let me show you the reaction. We initially have a diazo compound N2 plus Cl negative, plus the reaction right now is happening with aniline. Aniline contains NH2 group, which is a very activating group. This activating group is attached. This is working as an electrophile and attacks over. Electrophilic aromatic substitution reaction will take place, and this will be attacking over here. HCl will be removed in this condition. That's why basic condition is preferred in order to carry out this reaction, so that HCl can be neutralized. If I take this is how the product is going to look to me, and this is with NH2. Now, can you identify the compound? This is a yellow color dye. Please identify the correct option. I think everything is in front of you. Shrikar has submitted me the correct answer. I think Shrikar has submitted me A as the answer, which is not correct. Shrikar, I'm sorry to say you, but this kind of compound is, I think, option B. Option B is correct. Okay. We call it para amino diazobenzene. We call it para amino something like that only, yaar. Wait. In cold condition, the I think this is also not the correct answer. Cold condition, aniline is diazotated and treated with phenol to give a colored product. First of all, aniline is diazotated and treated with phenol. Actually, why am I carrying out this reaction with this, yaar? Our correct answer is this actually. My bad, man. Actually, aniline was not given to us. Aniline was just diazotated. Let me just rewrite the expression. My bad. Beg my pardon, everyone. But I can show you the correct reaction. How is it happening? This is NH2. Once it goes with the HCl and NaNO2 and completing the reaction at lower temperature, cold condition, this is how a diazo product will be coming to us, Cl negative. Once we treat this diazo product with phenol, and in basic conditions we are treating it because HCl will be getting eliminated out, and for this is how the attack will take place. Electrophilic aromatic substitution reaction will take place, and that's how you will be getting a final product as this is N double bond N, and then benzene is connected over here with a OH group over here. I think C is correct answer now. Who has submitted me C as the option? Preetha, Shrivansh or Rukmani. Great guys, great going. C is absolutely well. Let's have another question. See, yaar, being a teacher can also commit a mistake, yaar. Sometimes you have to adjust it, man. Huh? Anyways, now look at the question and tell me the answer. By the way, this question is automatically looking like octahedral complex to me because see, Cl negative is monodentate. Cl negative is a monodentate ligand, while oxalate 2 negative is a bidentate or didentate. So total denticity will be 2, and 2 into 2 is 4, 4 plus 2. So 2 plus 4 is equals to 6 is the coordination number. I think A is correct. Can I get the correct answer, everyone? Why are you submitting B as an answer? B can never be an answer, man. 6 is always correct as an answer. Coordination number has been asked. Okay, if you want me to draw the structure, I can draw it for you people, but don't waste the time. Okay, this is simple CR. What is the oxidation state? X minus 2 minus oxalate also has 6 minus over there is equals to positive negative of 3, and this is like 6 negative will give it positive 3, and I don't know how come is it having positive 5 oxidation state, but anyways this is how it will look like. Cl negative, then this is like OX, and this is also like OX. This is how the complex will look like. Anyways, the coordination number was asked here. Coordination number is 6, which is the correct answer. A should be the perfect answer. Now I'll take you to the next question. The question is pretty simple, and you already have solved such questions till now. The question is saying that if we make this reaction to happen, it's a, first of all, let me write this part that this reaction is actually a free radical. It's a free radical substitution reaction. Free radical substitution. The most free radical will give the correct answer, by the way. So guys, if I see it, where can you find the most free radical, most stable radical? A most stable radical will be the one which is balanced by the resonance. So this is, let's say if I'm removing H from here, so this radical is actually resonance balanced. This is a reso balanced and most stable, and then it will be attacked by Br radical to give you this as the answer. Now can you tell me the correct answer? Can you see the correct answer? D is the correct answer here. D is the absolutely perfect answer here that we can derive from the question. D. Hopefully all of you are doing well. Hopefully every one of you is doing absolutely fantastic. Let's come to the next question. So guys, let me remind you, like till here, how many questions have you solved? Just remove the 2 or 3 slides that we had in the initial. 36, 17 questions you have done till now. Now, can you imagine that out of 10 question or 12 question that is going to ask you in exam, I have solved 17 or 16 question, which are most predicted. So there's a high or huge possibility one of the question may appear in your exam, 2 of the question, 3 of the question, even all the questions may come in your exam. Okay, all of them are very important question, and that is what the target I had in my mind, that I'll make you solve that much number of questions that if you attend my class, this lecture will be highly sufficient for all of you to make your practice done. Let's see the another question. Which of the following is a homoleptic complex? Can you find an homoleptic complex over here? Homoleptic complex is the one that contains only one kind. Homoleptic complex is the one that contains only one type of ligand. Only one type of ligand is there. So can we identify the correct answer here? I think only one kind of ligand is there in this, which is containing only cyanide. Only Cn negative is there as a ligand. Rest others are containing chloride, ammonia chloride and nitrate. C is the correct answer. And believe me, a similar kind of question came in JEE Main 2024 also. So if you are doing well with your NCERT itself, you are pretty much able to crack your boards exam very well. Believe me, you can easily crack the chemistry of JEE Main, because JEE Main chemistry is absolutely coming out of NCERT itself, from nowhere else, only from the NCERT. NCERT is the god book to solve the chemistry for JEE Main. Next question says that ethylamine can be prepared by the action of LiAlH4 on what? So first of all, let's say if I'm gonna to get it reacted with LiAlH4, and let's say if it is going for the 100% of the reduction. So on reduction, a compound like CH3NH2 will be formed, which is methanamine, not ethanamine, and on this will be giving you CH3CH2NH2. I think this is correct. This upon reduction will give CH3NHCH3, which is also not gonna to be the compound. On this reduction, this will give you CH3CH2 and CH2NH2. This is propylamine, this is dimethylamine, this is ethylamine. Ethylamine was the question asked. B is the correct answer. B is the correct answer. Okay, I can see that people are not liking the session. Please guys, like the session. It will not take too much of yours. Just simply click on the like button. That's it, man. Somebody who has woken up the whole night in order to make sure that this session gets with you, session goes to you, I deserve a like at least. Let's write the IUPAC of this compound. Whenever the amines come in this way, we have to take a main chain first of all. This is the main chain 1, 2, 3, and 4. These will be treated as a substituent. The correct answer for this will be N, N dimethyl, N, N dimethyl methylprobute butanamine, or that's how we write it. So N, N dimethyl butanamine. I think butanamine or butane 1-amine can also be written. Butane 1-amine can also be written, because on first position it has been connected. D is the correct answer to me. Whew. Well, good guys, very nicely going everyone, very nicely going. Let's see the another question. This is the question, another objective question. So the question says that consider a reaction which is in A is in equilibrium with B. The concentration of both reactant and product varies exponentially with the time, and which of the following figures correctly describe the change in the concentration of reactant and the product? Okay, can you give me the answer, guys? Okay, try this question at least once, and until then I'm checking like who's doing it correctly or not, who is doing it rightly or not. Now let me take you to the next question. We have another question, everybody. This question is actually a very important question, and not just for the point of boards, also for the ports of JEE. A is in equilibrium with B, and we have to identify which of the graph is satisfying this thing. So guys, we all know that the reaction never works like this. The reaction, if it is gonna to happen, products will be zero at start, reactant will be highest at the start. With the time, product keeps on increasing exponentially, reactant keeps on decreasing exponentially. Where can you find this kind of graph? See, A is in B, so B is actually the product, A is actually the reactant. A is keep on decreasing, B is keep on increasing. This is the correct answer. And there we had there will be reaching towards the equilibrium. So there will be getting the equilibrium by where it is getting constant of the concentration. There we are getting the time of equilibrium, T equilibrium. So I think B is the correct answer. Now let me see who has submitted with the correct answer. J Advanced, Srikar, and these people have submitted with the correct answer. Let's see the another question from here. We have plenty of good questions, by the way. The reaction of ammonia with a large excess of CH3Cl. This is one of the very important reaction, everybody. So I would like to write this reaction for all of you. We have two things here. One of them is called as substrate. One of them is called as substrate. This is one of the substrate. Now this substrate is being attacked by NH3, ammonia. This will attack there. This will be replaced there, down over there, and then this will be giving you CH3. So I can write it in this way. CH3NH2. Okay, HCl will be eliminated out. In this reaction, if you are taking a large excess of this is an excess, then every time this will be your another nucleophile will go and attack over there, and the reaction will keep on happening like this. If this is the reaction, then again CH3Cl will be there. This will go and attack there. Chloride will be removed out one after HCl. This will give you CH3 whole twice NH, and the reaction will go on like this, and finally what will be formed? CH3 whole 4 N positive Cl negative. A quaternary salt will be the product. A quaternary salt will be the product. And let's say if I carry out the same reaction oppositely, as in I'm taking CH3Cl, if I am taking CH3Cl in limited amount and ammonia has been considered in the excess, then what will happen? There will be only one substrate to attack upon, and the final product will be CH3NH2. Primary amine, 1 degree amine will be the major product. So please remember this reaction. It's going to be a very important reaction, and not for only the JEE point of view or for the ports point of view. In JEE also this is going to be very important. The correct answer should be, tell me the correct answer. I think C is the correct answer. C, who has submitted me? C, J Advanced, Shrikar, Shri, Vansh. Very good guys, keep it up. I'm expecting more people to join me. I'm expecting more people to respond me on these questions. There we end up with this title, Let's see the another question. So what do you think? Which of the following reagent is going to be used for Hinsberg test of amines? Where do we use the Hinsberg test? Hinsberg is a test. Hinsberg test is used for identification of primary, secondary and tertiary amines. Primary reacts with the Hinsberg reagent and also gets dissolved into basic medium or alkaline medium. This is called as the primary amine. And for secondary amine, they react only with the Hinsberg reagent, doesn't get dissolved in the basic medium. And tertiary do not even react with the Hinsberg reagent. This is a test of primary, secondary and tertiary amine. What is this Hinsberg reagent? The Hinsberg reagent, actually the reagent that we use is called as Hinsberg's reagent, also called as benzene sulfonyl chloride. How to write its structure? There is a benzene ring with S double bond O and one Cl group. This is benzene SO2Cl. Benzene SO2Cl. D is the correct answer. Can you identify the correct answer, guys? Can you identify the correct answer? Who has submitted me the correct answer here? I think D is correct, and mainly of you have submitted me the correct answer. Okay. Hopefully, I am pretty much understandable to all of you, because hopefully, right? As I told you guys, I don't teach boards basically in that much frequent classes, but yeah, I teach JEE and mains and advanced also, and on this very much channel you will be availed with so many benefits. So please guys, those who are new to this channel and who are right now watching me at the first time, please like the session and please subscribe to us also, because in upcoming days I'll be coming up with more other beautiful sessions also. I will ask my mathematics faculty also, I'll ask our Ayush Patni sir also to attend one or to conduct some such kind of session, okay, in mathematics as well. So please like the session and let's move forward to the next question. There we had it, we have made it, guys. There are plenty of questions. We solved around 20 plus questions for 1 mark question, and we literally took around 30 to 40 minutes only. If we are going with the same pace, we'll definitely be cracking whole paper now with all the practice done. We are right now on ARQ. What is ARQ? Assertion, reason, question, the one which was a very difficult question for all of you, the one that you always demanded me for. I have plenty of such questions to solve up with. Let me take you to first question of the day. The question is simple and says that NF3 is a weaker ligand than N. So guys, what does a ligand do? A ligand try to make a bond over here, but fluorine, being more electronegative, extracts the electron density towards itself, and that is what the other fluorine do it also. Because of the negative of inductive effect of fluorine, this statement I will pick it as true. Then NF3 ionizes to give F. Okay, because CS3 over there, CS3 doesn't have more electronegativity than nitrogen, so it will not attract the electron pair from nitrogen, not try to absorb the electron pair. But NF3 ionizes to give fluorine, which is an incorrect statement. It's a false statement. Okay, NF3 doesn't ionize in the aqueous medium. So what do you think the correct answer is? I think A is correct, B is false, C is the correct answer. C is the correct answer, guys. Guys, please keep on solving the questions, and rather than unnecessarily asking me so many things which I can't answer for. Okay, please go ahead. We do not have any specific language based channel, but I think hopefully I'm pretty much understandable to all of you guys. My English is very native English and very pure English. I don't speak too much of the very random and very difficult words. So I personally find that it is pretty much audible to every one of you, understandable to every one of you. Please solve the questions with me and try to submit your answer along with me. C is the perfect answer, guys. C is the perfect answer. Next question is, assertion says that D plus glucose is dextrorotatory in nature. That is what the plus sign means. This plus is actually giving you this idea. This plus sign is giving us the idea that dextrorotatory in nature. Negative sign means levorotatory in nature. But this D, capital D, this capital D is also called as relative configuration. This is called as relative configuration, and this gives you an idea that last chiral carbon has OH group on right hand side. On right hand side, if it is on right hand side, we call it D. If it is on left hand side, we call it L. That is what the meaning of D and L over here is. Now, can you identify the correct answer? So I think this is true and this has become false. So one of them is true, another one is false. Which answer can be the correct one? I think C is the correct answer. You might be wondering, have I come up with only these kind of answers? Assertion is correct, reason is false. Not like that, not like that. This part is absolutely clear to all of you guys. C is the correct answer. Can I move forward now? C is the correct answer here. Nobody has submitted with the correct answer till now. Okay, J Advanced has submitted with the correct answer now. I can completely see your chats and I'm continuously watching your chats. Okay, so do let me know the correct answer in the comment section itself, and if you face any kind of doubt, do let me know in the comments itself. Let's see the another question, the another assertion reason question over here. Assertion says that despite of having an aldehyde group, glucose does not give you 2,4-DNP test. Does glucose doesn't give you? Okay, 2,4-DNP test is given by the aldehyde and ketone. So that definitely aldehyde ketone group might not be available over there in the chain itself, because it doesn't, glucose molecule doesn't remain as a open chain molecule. Instead it remains in the form of what we call it, cyclic form and hemiacetal form, we call it hemiacetal form. So I think CHO group is not available. This is true statement. Okay, this is important. Basically this is a true statement. Glucose is a reducing sugar. Glucose is a reducing sugar. Do you know what is the meaning of reducing sugar? Those which have a CHO group with them or CO group with them, and so that is called as a reducing sugar. Even all the monosaccharides, glucose, fructose, mannose, ribose, all monosaccharides are reducing sugar. So don't worry in that. It is also a true statement. Probably this is not a correct explanation. Let me check correct answer. B is the correct answer. It is not correct explanation, but yes, both of the statements are correct. B is the correct answer. Correct. It reduces tolerance region. Yes. Let's see another question. So guys, till now, whatever the question we have solved, we haven't faced even a single level of difficulty. You people are solving the questions with me. I'm also solving with you only. We're trying to pick the correct answer out of it. Nobody has hesitated till now. None of the questions has gone incorrect. And we have seen lots of questions now. So guys, try to understand these questions. Try to grasp the knowledge that this is going to be the answer. Because believe me or not, plenty of these questions are going to be seen in your coming exam. Let's have another question. Assertion A says that rate of constant. The rate constant determined from the Arrhenius equation is fairly accurate for the simple as well as complex molecule. So Arrhenius rate constant determined from this are this. No idea on that, but plain you have to consider it as true. This is correct actually. The rate constant determined from the Arrhenius equation, like K is equals to A into e to the power minus EA by RT, gives you an idea about the K, right? The reactant molecule undergo chemical change. The reactant molecules undergo chemical change irrespective of their orientation. Okay. The reactant molecule undergo chemical change irrespective. This is a false statement. This is a false statement because if the orientation is incorrect, despite of having the enough and sufficient amount of energy called as an activation energy. If a reactant molecule has enough amount of energy, but it still has a incorrect orientation, it will not giving you a proper product out of it. If you want to get the proper reaction done, then the orientation, which is called as the probability factor, and e to the power minus EA by RT, this is the factor that gives you an idea that how many number of molecules are having their energies greater than EA or equals to it. So both of the factors are required, energy barrier as well as orientation barrier. The correct answer should be, the first one is true, another one is also, no, another is false actually. Can I check the answer? A is correct, R is false. Correct guys. We are right. C is the correct answer. And hopefully you people are also submitted with the correct answer over here. Some of you have done it. Some of you have done it. I can see some of you have done it. Not every one of you. Let's go to another question. We have a question. Assertion A is saying that for the reaction, this reaction is happening. Here is the arrow. CaCl3, Cl2, CCl4 plus HCl. The rate of reaction is this, which I have no idea upon. But yes, what we can see is if our rate expression is given to us, this is an experimental driven data. This is something that we cannot assume by our own, because if a reaction is an elementary reaction which happens or which takes place in one single step, for that it is pretty easy to identify the order of reaction. But if some reaction is happening in more than one step, in that reactions we cannot simply write the expression like this. But yes, in this reaction it has been dedicatedly and completely written as a practically driven data, so we are writing it as true. And now look at the another option given, that rate law of any reaction can be predicted with the help of a balanced chemical reaction, which is a false statement. Why am I saying it's a false statement? Because this is possible only for elementary reactions. What are the elementary reactions? The elementary reactions are the one which happens in one just single step. If some reaction takes place in one single step, only for that reaction a balanced chemical reaction can give you the exact idea of the order of reaction. But if a reaction is occurring in more than one step, in that reaction, in a chemical balance reaction, you cannot easily identify the order of reaction. For that you have to try so many other methods to identify it. Okay, I think this is true and false. First is true, another one is false. I think C is the correct answer. We had so many questions with first true and second false, and I guess this is also the correct answer. Absolutely correct, guys. Sir, why does the Arrhenius equation sometimes fail for complex reaction? Arrhenius equation doesn't fail. I haven't told you this part. Even for a complex reaction, Arrhenius equation will give you the exact correct idea, because the rate constant that we are getting for a complex reaction will be directly dependent on the slowest step of the reaction. In the whole reaction process, there is a slowest reaction for which you are right now applying the Arrhenius equation for. That's why Arrhenius equation will never give you the incorrect idea. Yes, by using the steps of reaction or multiple steps involved in it, you cannot identify the order of reaction directly by simply using the slowest reaction. There is a process which is required in that whole. But yes, Arrhenius equation is the one that can help you to identify the rate constant K, even for an elementary as well as for the complex reaction. Now I'll take you to the next question, guys. I hopefully have made you understand the correct explanation for the previous question. My God, how many questions I have come up with, man? I think it's like a 10th or 11th kind of assertion reason we are right now having, and only 4 questions are going to come in your exam. This is what kind of preparation I always wanted for all the student. Now let's take the idea of another question. Assertion says that if one of the component of a solution obeys Raoult's law over certain range of composition, then the another component will not obey Henry's law in that range. I still have no idea what it's trying to say. One of the component, if one component of the solution obeys Raoult's law over certain range of composition, then the other component will not obey Henry's law in that range. Actually, Raoult's law and Henry's law, both of them are the same only. Even Raoult's law is one of the special case of Henry's law only. This is true. Can I check the correct answer? I think both assertion reason are correct and reason is the correct explanation. Okay, fine. So let's take it true as well. If one of the component of solution obeys, let's say one component of the solution, I don't know what is the meaning of that. Maybe it is asking about a particular composition, that at a particular composition then the other component will not obey Henry's law in that range. And this question has been asked in 2020, 2017 as well. Everybody is saying, sir, A is the correct answer. Seems like you people have seen this question earlier, okay? I'm not getting too much of the idea out of it, but yes, one of the component of the solution obeys Raoult's law over a certain range of composition, and the another component will not obey Henry's law in that range. Okay. We'll come to it anyways. We'll come to it. Just take an idea. Now learn for now. A is the correct answer. Please, if the same question comes in your exam, mark A is the answer. Let's come to the another question. I'll see that question once again and I'll bring that concept. Okay, let it come in my mind first. We have another question that iron on a reaction with HCl gives FeCl3 and not FeCl2, which is a false statement because initially iron will give you FeCl2, not FeCl3. And because in this reaction, if you see the reaction takes place in this way: Fe plus HCl gives us FeCl2 plus H2 gas. This H2 gas, which is reducing in nature, doesn't let Fe2 plus 2 oxidize further. It will not let oxidize Fe2 positive to further. So the correct answer should be A is incorrect and B is correct explanation that has been given over here as well, what I am explaining right now. So B is true, reason is true and statement is the false statement, assertion is false. So A is incorrect, B is correct. I think 4 is correct. Another question, guys, another question. So try another question. Assertion says that benzoic acid, we have benzoic acid and benzoic acid does not give Friedel-Crafts reaction. Does it? Because you know what Friedel-Crafts reaction is? The electrophilic aromatic substitution, and because of the presence of this C double bond O group, this is an electron withdrawing group, and this electron withdrawing group doesn't react. It deactivates the deactivates the benzene ring. Electron withdrawing group deactivates it. So first of all, I must mark this statement as true. The another one is carboxyl group deactivating group, yes, and it is also bonded to the Lewis acid AlCl3, which is also true because of the presence of this O negative over here. It gets bonded with the AlCl3 itself, forming a salt or a positive negative charge containing salt. What do you think correct answer should be? I think both of them are correct and a correct explanation as well. Can I see correct answer, everyone? So we have the Rising Nerd, we have J Advanced. These two students have submitted me the correct answer. A is the correct answer for this question. Shrikar has also submitted me the correct answer. Okay, Shrikar. A is right. Next question. Molality of a solution in liquid state changes with temperature, which is a false statement because molality is actually temperature independent term. This is actually temperature independent term. All the concentration terms that do not involve volume in it will be temperature independent, and anyone that contains volume in it will be a temperature dependent concentration term. In the reason the volume of the solution changes with the change in temperature, which is true. I know it is true, but again, molality doesn't contain any. Molality has a formula of given mass upon molar mass into 1000 divided by the mass of solvent in grams. So there is no volume as such in this formula. So answer, assertion is false, reason is true. Correct answer should be fourth. So guys, that's it. And now I'll take you to the 2 marks question straightforward from here. But allow me a second, everyone. Please allow me a second. I'll be back in 2 minutes. I'll be back in 2 minutes. Let me get water for myself and I'll be back very soon. Okay. Sir, what is the relationship between, can you derive the relation between molality? But why do you want me to derive it, man? What is so difficult in that? It's very easy. Okay guys, let's continue. So you know what, we have plenty of questions to practice here, and not just the plenty of questions, these questions are the one which are actually most repeated questions. Okay, so these are very potential questions which can be asked in your coming exam. So please try to solve these questions along with me and try to submit your answer in the comment section so that even I can correct you if you if you attempt them incorrect or wrongly. I'll help you. Okay. Anyways, if you want to know the derivation, the raising word, I'll explain it at the end of the class. Okay. Until then, please keep patience. Okay. We don't want to waste the time because everybody is not here for that derivation. Please. So we have a 2 marks question, guys. Short questions straight away. Let's start the first question. We have, give the IUPAC name and the structure of the amine which is obtained when 3-chlorobutane butanamide undergoes Hofmann. So guys, actually this is a 2 mark question. Till now we had just a option based question, single choice question. So for that you are not supposed to write the whole thing. You can simply mark question like question number 1 and then answer A, B, C, D, like that you can do. Okay, it's just a single alphabetical answer you have to write. But over here you have to bring something to write down. Okay, and it should be very specific. Let me be very sure. It can be a 1-line answer also, but it should be very to the point thing. Okay, IUPAC name of the structure and the amide of the amine obtained from this. So first of all, we'll write that structure, which is 3-chlorobutane amide. So butanamide is meth prop but. So butanamide is C double bond O NH2. This is 1 carbon, this is 2 carbon, this is 3 carbon, 3, and this is 4. 3 is connected to chlorine also. Now let us basically make them complete number of carbon atoms as well. This is how we have to make it. We are gonna to make it react with NaOH and Br2. This reaction is called as Hofmann bromamide reaction. This is your Hofmann bromamide reaction or degradation, and this reaction will lead you to the products of where CH3, CH, Cl, CH2, and this will be connected with NH2, and the CO2 will be eliminated out. The CO2 will go and react with the NaOH acid base, Na2CO3 will be formed as a product. This is your compound that is going to be formed in this reaction. Let me write this compound. 1, 2, 3 are the carbon atoms. This will be called as 2-chloro method prop propane 1-amine or propaneamine or propane 1-amine. This is the actually answer that was required from your end. So simply try to write the reaction, try to be more perfect as possible. Hello?
Good evening, Satya sir. तुलसी बात कर रही हूँ FPS job से.
From where?
FPS jobs.
Ma'am, actually right now I'm in the lecture, okay? Maybe we'll be connecting later on.
Okay.
Thank you. That's it. Let's move to the next question then. So your 2 marks question should be straightforward and very much to the point, not writing here and there things. How many ions can be produced? So you should mention it clearly, writing CO NH3 whole 6 NH3 whole 6 Cl2. So write in dissociation in water aqueous medium, whatever it is there in the coordination sphere will keep intact with a 2 positive charge. Aqueous plus 2 Cl negative ions will be there, whichever it is present outside of the complex. Something which is present outside of the complex will be removed out. Okay, that's how we do it. Okay, next question please. Simply that is what it is required for 2 marks question. No need to write too many things. Okay, complete and balance the reaction. So guys, in these question we have to balance the reactions also. So let me remind you, this involves the concept of redox reaction. Hopefully you all have undergone these reactions by your own also. I'll explain you one of the example and then I'll take you to the next question, next basically answer also. Iron 2 positive, MnO4 minus. Okay, no doubt this is a redox reaction. Iron will be oxidized to 3 positive and Mn will be reduced to 2 positive. This happens in acidic condition. This is present in positive, this is present in positive 7, this is present in positive 3, this is present in positive 2. Now can you identify the difference, or we can call it the N factor or change in oxidation state? This is 1 and over here this is 5. The N factor over here is 5. Just cross multiply them, this will become 5 Fe2 plus 1 MnO4 negative gives you 5 Fe3 plus Mn 2 positive. Now how many number of oxygen are there? Exactly that number of water molecule we have to add in the opposite side, hydrogen deficient side, and as many as number of oxygen are there, exactly same number of, sorry, there are 8, there are 4, so 4H plus also has to be, sorry, 4, what I'm saying is, okay, 4 oxygen is balanced, hydrogen is not balanced, 8H positive has to be added. This is now your completely balanced chemical equation. Now please try and do the same for this reaction also, where I know we have not mentioned in acidic or basic condition. In neutral condition, the iodine will be going, or slightly alkaline medium iodine goes to iodate ion, plus this will be converted into MnO2 in positive for oxidation state. Now you can balance it by your own. Try to solve it in the same way as I have done it. And this is how you're getting your answer with, okay, 8H plus 5, 4 like that, and you will be getting the same also. Very good, N factor 5. Raising nerd, you have made it, you have cracked it. Very good guys, keep it up guys, keep it up, show your josh. Okay, don't fall asleep. Let's see another question. Okay, this is something very easy, man. In a 2-mark question, straightforward. Phenol to toluene. What is phenol? What is toluene? Phenol is this. Okay, you should do these question in as minimum as number of these steps, as reduced as the concepts. Okay, but you have to basically restrict yourself up to the number of steps you are taking. So in first step, what you will be doing, simply heat it in the zinc dust. You all remember zinc dust reaction. It will give you zinc oxide as a product, and you will be getting benzene along with zinc oxide. This benzene will be getting reacted with CH3Cl along with AlCl3. This is called as Friedel-Crafts alkylation. Alkyl group will be attached over there. This is the product that you were looking for. That's how you can carry out the first question. Right guys, very easy. Now let me take you to the next question, and the next is saying that there is a formaldehyde HCHO, and we have to make it ethanol. Ethanol is actually containing 2 number of carbon atoms. So if you want to add 2 number of carbon atoms, make it reacted with Grignard reagent CH3 Mg Br. This CH3 negative, Mg positive. CH3 go over here. This will become O negative. The product will be, this is CH2. This is O negative. This is O negative. Mg Br positive, and then CH3 has attacked there. In the next step, I'll treat it with water. Then this will be giving you CH3 CH2 OH plus. The byproduct will be magnesium along with bromine that was already attached, and 1 OH of the water. So guys, this is how we can prepare ethanol from formaldehyde. This is your 2-mark question straight away. You will be deducted with 0 mark over here. You will be rewarded with complete full out of full marks, because the way I'm explaining you do not require any further explanation. Keep it straightforward, to the point. It is again going to be very easy for the teacher that is going to check it. He will be impressed by the work you have done. If you write it unnecessarily so many things, that teacher will feel it like, okay, somebody doesn't know the answer and trying to fool me out of here. Let's see another question. Let's see another question. Let's see another question. Name the cell in which is used in hearing aid. Hearing aid we use, I think, button cell. Button cell. We also call it zinc and mercury cell. Zinc amalgam cell. Okay. The first answer is pretty easy. No need to write anything in extra. No need to write anything in extra. On which factor do the product of electrolysis depend? There you can mention a few points, like number 1, what kind of electrolyte is there, nature of electrolyte, right? Whether it is aqueous or molten, which is also type of electrode you are using, if electrode is participating in the reaction or not. So that 2 points are enough, I guess. Okay, you will be getting your 100% marks. That's it, I think. Do inert electrode participate in the reaction? So first of all, the answer should be no. If the name itself is inert electrode, how can is it supposed to participate in the reaction? What is the role of an electrode? Number 2. What is the role of this electrode? The role of electrode is to provide the conduction by transferring electrons. Now see, even if I mention it like this, I will be getting 100%, 2 out of 2 marks. So no need to write down anything in extra. Be very specific. If it is a short answer has been asked, it's a 2-mark question. If you write it unnecessarily in the extra, you will be definitely wasting your time at this point of time. Okay, so do not waste your time. Okay, for conducting electrons, very good. We have another question. There are 2 complexes. One of them is this, another one is this. So it's asking that different magnetic behavior is why. So guys, you will be writing this is Ni2 positive in the first. If I talk about, you can explain like me. I would have been there in your examination cell. This is how I would have solved this question. In this, I can see nickel is present in positive to oxidation state. The configuration is argon 4s0 3d8. Cyanide, being the strong field ligand, will try to pair up the electron. This is your 3d. This is 4s0. This is also 4p0. And why the pairing is happening? Cn, being strong field ligand, does pairing of the electron, but possess same magnetic behavior, but they have different structure. So guys, the hybridization over here will be dsp2, this 1d and sp2, because 4 ligands are approaching. This is hybridization is dsp2, and geometry or the structure will be square planar. But if I do, and the number of unpaired electron are 0, and that's why it will be called as a diamagnetic species. Now look at the another example that we are having right now with us, which is nickel tetracarbonyl CO4. Nickel is present in 0 oxidation state. Oxidation state is 0. The configuration will become argon 4s0, 3d8, 4s2, 3d8, 4s2. Now 1, 2, 3, 4, 5, 6, 7 and 8, and this is having 4s2 and 4p0. So now CO being a strong field ligand does pairing of electron. These electron will jump over here. This will become like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0, 0. This is S, 4s, this is 4p. The hybridization will be sp3. sp3 has a tetrahedral geometry. Again, the number of unpaired electrons are 0. The reaction, this will also be magnetically diamagnetic. That's it. So that is how you have to explain. Although, sir, how to get 35 marks? 35 marks. You will get it eventually because you will be getting 30 marks from practical. You just try to solve one 5 marks question then. Oh, it was a funny question, by the way. Let me take you to another question then. What is the effect of adding a catalyst? What is the effect of adding an extra catalyst on EA? So basically, do you know what does this EA, what happens to EA? So on adding catalyst, activation energy of the reaction decreases. Because of the decrease in the reaction easily goes in forward direction, and the rate of reaction increases. Number 2, if we talk about the spontaneity, so delta G. Well, delta G is a function of enthalpy, change in enthalpy, and there is no change in enthalpy takes place because the product and the reactants are still at the same energy level. The only energy level that has changed of the transition state, which we call it as the activated complex, or this amount of energy is called as activation energy. Activation energy has been decreased, but energy level of reactant product are still the same. Reaction might have gone faster, but delta G doesn't change with addition of catalyst. So there is no change on delta G, and adding catalyst EA decreases, and thus the rate of reaction increases. This is what the correct answer is. Let's be to the specific, to the point answer has to be written, and come back to the next question. MnO is basic, whereas Mn2O7 is acidic in nature. What is the reason behind it? So first we will write it in this way. See, you need to mention it. MnO has a positive 2 oxidation state, has plus 2 oxidation state, thus accept electron pair and behaves as Lewis acid, has and donate. Since it can donate electron pair, it can work as a Lewis base, while Mn2O7 has positive 7 oxidation state, can only accept, it cannot donate electron pair because it doesn't have electron pair. It can only accept electron pair behaving like Lewis acid. That's the correct answer. B. Transition metals form alloys. Do transition metal form alloy? Is it true? Yes. Yes, because transition metal atoms have nearly the same size, thus can easily form alloys. So basically there is a condition, it's given in the NCERT itself, that the delta of the radius should be lesser than 20%. If it's lesser than 20%, that means they can be easily fit for the alloys formation. Another metal atom can fit into the ones, or we can simply say their lattices can be intershifted. We can simply say that one can occupy the another one's lattice, or another one can occupy one's lattice. So this is how the alloys are formed, and it is strictly dependent upon their sizes. If the atomic sizes is quite similar, then they can easily form the alloys, and that's why so many alloys have been formed using these, like copper, zinc. They form various of the complex, various of such brass, like kind of alloys. Okay, let it be, man. Now I'll take you to the another question from here. Why is the osmotic pressure of 1 molar KCl is higher than 1 molar urea, and what type of liquid form ideal solution? So first of all, let me answer first question. You have to first write that the osmotic pressure, which is actually osmotic pressure pi. Osmotic pressure is a colligative property which is dependent on ICRT. C is the molarity, I is actually the Van't factor. Now I for KCl being a strong electrolyte is 2, giving K positive and Cl negative, and I for urea, which is a non-electrolyte, is 1. You can simply mention it, it's a strong electrolyte. And the urea is a non-electrolyte. That's how you can give your answer. Okay, you can get the value of osmotic pressure. So that's why pi for, if it is Y, then we'll say pi for KCl under all similar condition will be more for pi for urea. Okay, you can also elaborate it, explain it by writing down the molality. Okay, writing down that. So tell me how can a guy 35 or 70? I'll take you there. Okay, don't worry guys. Please wait until my last question. Then right after that, I'll take a simple doubt discussion session where you can ask me anything you have in your mind. Okay, anything. Number 2. What type of liquid form ideal solution? Those liquids which have similar type of forces of attraction between them as together and as together. Those have similar type of force of attraction, like FAA is approximately equals to FBB is approximately equals to FAB. These type of liquid form what? Ideal solution. You can also give an example like benzene plus toluene. Benzene plus toluene. You can also show some examples. Okay, so guys, whatever the question comes in your mind, no, please don't be hesitated, but there will be a certain time right after this session, right after finishing the last question, that is of 5 mark. I will ask every one of you, I'll take a free ask me anything session. There you can ask me anything, not just about the academics, even anything comes in your mind, do ask here, no problem, but not right now, because otherwise this will basically break my momentum which is right now going on. Okay, I don't want to break my momentum. Let's see the another question. We have propane 2-ol which is heated with copper at 570 degrees. This is called as atmospheric oxidation. Okay, so we have propane 2-ol. This is propane 2-ol. We are having copper. We are having 573 Kelvin. This process is actually an oxidation process. We'll be forming CH3 C double bond O. Propane is the correct answer. Okay, you can also write the correct term. This is actually propane on or propane 2-on, exactly the same. This was propane 2-ol. So you have to mention everything. Okay, this is propane 2-ol. Propane is the final answer. Number 2. salicylic acid. You know what is the meaning of salicylic acid? This is benzene with one OH and one COOH. This is called as salicylic acid. If it is CHO, this is called as salicylaldehyde, and it's been treated with acetate. So this is CH3CO whole twice O. So now this is the one of the SN2TH type reaction. This lone pair goes there, attack on the carbon and remove out the acetic acid out of it. So the correct answer will be benzene O, C double bond O, CH3. This is acetate group, and this is COOH plus remaining part of this acetic anhydride CH3CO. CH3COO will accept one H plus from the acid, and this is how the reaction goes on. So guys, please try to understand. I am not being a bit fast over here probably, but I just want to give the answer of everything. So first of all, let me explain this reaction to all of you. This is your OH, this is COOH, and this is how acetic anhydride looks alike to us. Now this oxygen attacks on the carbon, and this is how this group comes out of it. This will go, okay. So under acidic condition, and under acidic condition we are going with this reaction. So this O and H will be removed out from there. This O will be looking like this, is attached over there with the directly with the carbon. So this is an acetate group with COH group. So what is the name of this compound? We call it ortho acid oxy benzoic acid, which is also called as aspirin. One of the medicinal purpose we use it for. This is called as aspirin, and the remaining part will be, this is the CH3C. OCH3 was coming out of here, CH3O, C double bond O, and it will become what? So here, I think I have unnecessarily mentioned so many O over there. Okay, this is not OCH3, this is simply CH3, like this. This is also CH3. Now this is absolutely correct product. CH3COOH, acetic acid also as a product will be getting. So we are supposed to take the name of the product only, and we have to write the reaction very neatly and carefully. I think if you do like this, what I have done over here, you will be getting 100% of your marks. Literally 100%. That is 2 marks. We have most repeated question, guys. Let's see what is most repeated question. Lengthened contraction. So you have to define it properly. You have to mention its consequences also. So what is lengthened contraction? Let me see if I have come up with its answer or not. No, we do not have its answer. So let me write it. So lengthened contraction is a continuous decrease in the size of lanthanides with increase in atomic number of lanthanides due to the poor shielding of F subshell is called as lanthanide contraction. Is called as what? Lanthanide contraction, LC. You can also show this diagram. If you remember all them, this is lanthanides, this is the radius of lanthanide 3 positive ions, and this is actually the atomic number, and there's a straightforward decrement where you can show started from lanthanum La3 plus and then started from Separ and Pumsum. You got तब दियो यार तुम ये भी low. So guys, this is how you can completely show, and believe me, if you write it in this way and you also mention this diagram, nobody will hesitate to give you pura 2 out of 2 marks. And writing now about its consequences, it has multiple consequences. So consequences will be consequences of lengthened contraction. Hopefully you all have studied about lengthened contraction in DNF block, but yes, it's basically popular in complete modern predictable. So the first consequence of lengthened contraction is that the size of 4D and 5D and that of 5D and 6D are quite similar. Well, this is because of the lengthened contraction, this is because of the actinide contraction. But anyways, I think we have to mention only up to here. No need to mention the actinide contraction unnecessarily. Are quite similar. Another could be, do you know what the radius of ionization energy, first ionization enthalpy of what was this? Scandium, titanium, vanadium, chromium, manganese up to zinc, yttrium, zirconium, niobium, molybdenum, technetium, vanadium, rhodium, up to cadmium, and lanthanum, hafnium, tungsten, mercury, and then we have actinium, and then the sodium, diborcium, seaborgium, selenium. So guys, you can easily see that there are the lanthanides. Okay, here are the lanthanides. So you will see that the first ionization enthalpy of hafnium is greater than zirconium, IE1 of zirconium, while you will see that ionization enthalpy of yttrium is greater. Okay, yttrium is greater than, like lanthanum has lesser than IE1 of yttrium. You can please give this thing. This is the proper consequence I can mention using these 3D, 4D, 5D series also. So this is the question from DNF block element. If you mention it like this, I have done it. Nobody is there to cut your marks. Everybody will give you full out of full marks. Okay. Okay, then I'll take you to the next question then. Hopefully this is enough for all of us. Let's see the another question of 2 marks. It's a most repeated question. It's also high order thinking question. And let's see how do we proceed. Which of the following compounds will give you undergo SN2 reaction faster? So you have to also give a support. Okay. So guys, how can we simply say it? That see the rate of SN2 reaction is directly proportional to the stability of leaving group. So how it's more easy to be removed as a group. Higher is the stability of the leaving group, higher will be the stability of the, or higher will be the rate of reaction. So in this, who will give the faster rate of reaction? Iodide, because iodide is relatively more stable than chloride. That is first logic. Second question, we all know that this is the correct answer. So this is the rate of reaction, because the rate of SN2 reaction is directly proportional to 1 upon steric hindrance. Okay, if you want to write it properly, you can also write it, but let's say if you leave the question like this, I barely think anyone can cut your marks. I don't think anyone can cut your marks, because this is self-explanatory from here also. But if you want to write 1 or 2 points, you can also write like this. In first, you can write that iodide being more easily leaves as a leaving group than chloride ion. This is the first thing. Second, you can write that for SN2 reaction, which are one-step concerted reaction, the rate of reaction directly depends upon the lesser is the steric crowding, higher is the rate of reaction. That's what you can explain in the second point, and you will be getting perfect 2 out of 2 marks. Third question came in 2017, 2013, and now it will be coming in 2025. Mind it. How will you convert ethanol? Ethanol is what? CH3, ethanol, C double bond H. So this is first we have to convert ethanol to ethanol. So use any reducing agent like LiLH4. Use LiLH4. So it will be converted into CH3 CH2OH. That is the first reaction. Number 2, ethane. So we are having CH3, C double bond OH. So there are two reactions. One of them is called as Clemmensen reduction. Another is called as Wolff-Kishner. Either of them you can use and you can identify the final product. You can convert it into CH3, CH2, or like simply CH2, CH3. This is called as ethane. Please write the name properly. Otherwise, no, but that is it. Okay, this is called as ethanol. This is ethanol. Ethanol. Sadahak, etharak. Ethanol. So this will be the reagent will be concentrated at Cl and amalgamated zinc ZnHgHCl. This reaction is called as Clemmensen reduction. You can also use N2H4 hydrazine in basic condition OH minus. This will be Wolff-Kishner reduction, and both of the reactions can be used because none of the acid or base sensitive group has been given in this compound. You can use both of the reactions. Okay, that's how we do. You will be getting complete 2 out of 2 from this question. Another question which is very much repeated and it's like pakka aayega. One of my friend also teaches in 12th standard and he suggested me that Sanjay sir, this question is very much sure. Aisa question jarur aayega. So this kind of question may come in your exam. Explain all the steps which are involved in the chemical reaction can be used for the preparation of potassium dichromate. So potassium dichromate is prepared from the chromitor. Chromitor is FeCrO4. Let me show you how is it for. So you not need to balance the reactions. If it is asking for the balanced chemical equation, no, then you can simply write it that FeCr4 under basic conditions on attack with the oxygen produces Na2CrO4 and Fe2O3. So what is this NaCrO4? So NaCrO4, okay, sodium chromate, NaCrO4. Then NaCrO4 under acidic condition gives you Na2Cr2O7, also called as the sodium dichromate, which with potassium chloride gives a double displacement reaction. And produces what? Your final product is potassium dichromate, which is less soluble than Na2Cr2O7 in water. It is less soluble, and that's why orange colored crystals will be obtained from this compound. If you go for the further what we call it, that process, crystallization. If you go for the further crystallization, you can easily separate out the proper crystals of the potassium dichromate. So guys, this is a very important formulation. Kindly please learn down these reactions. Okay, doesn't require to explain it anymore. Fine then. Whew, man, I'm feeling a bit tired now, but it's okay. Let our energy be continued. Okay, don't you just put a stop on your energy. We till now over here have solved all 1 mark question, all 2 mark question, and believe me, there were plenty of questions. We just had around 30 plus questions I have solved for 1 mark question. More than 20 questions I have solved for 2 mark question. Now I have 3 mark question, which are like the highest number of questions in this segment, because around 14 questions will come. Not 14, I think 7 questions will come in your 3 mark question, right? 7 questions come from 3 mark. So I would like to give you plenty of questions, like 15 to 20 questions I'll be explaining from 3 mark right over here, standing over here in front of you, so that you can become comfortable solving all 3 mark question. Until now we haven't faced even a single question that can stuck us. So let's go and figure out what questions are there for 3 marks. So number 1 question which came in 2022, 2018, 2016, 2015 and 2013. So this question is that write the hybridization shape and magnetic character of cobalt hexafluoride and write the formula of pentamine this also. So let us see. First of all, I'll do the first question. Be very specific toward the answer. Don't overwrite the question. Hybridization shape and magnetic character. So first of all, you will write it like this: COF6, 3 negative. So x plus 6 times of minus 1 is equals to minus 3. X comes up as positive 3. So you will write over here that cobalt 3 plus has an electronic configuration of what? Argon, 4s0 and 3d7. No, 3d6, 4s0. Okay, because 4s2, 3d7 is the configuration. 3 electrons are removed, 2 from here, 1 from here. So this has become 3d6, 4s0. Now we know that fluoride being weak field ligand only. Fluoride will weak field ligand. These 6 electrons will be filled in this way. You can also apply the what I call it. So fluoride being weak field ligand does no extra pairing. come to the next part of this page and then solve it like this. So write it in this way. D6 configuration, splitting will take place for an octahedral complex. This is your T2, this is T2G, this is EG. How many electrons do we need to fill? 6 electrons. So 1, 2, 3. Since it's not a big gap, electron will go up. And you can also mention, because of fluoride we are using, delta O is lesser than the pairing energy. That's why electrons are jumping over there. 1, 2, 3, 4, 5, 6. So what is that is asking? Hybridization. So okay, what will be the hybridization, dude? We know that this is 4s0, 4p0 and 4d0 as well. This has been occupied and we require 6 number of ligands to fill up in. So sp3d. So hybridization will come sp3d. How many number of unpaired electron can you see? Shape or geometry will become what? Even for d2sp3 or sp3d2, it will be octahedral. Number of unpaired electron can you see? How many number of unpaired electron can you see? 4. That's why this species is called as paramagnetic in nature or magnetic in nature. Paramagnetic nature. That is your first answer is A. Next is, what is the formula of pentamine dichloride, blah 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 blah. So I think I can write the correct answer over here also. Your second question I am writing over here. Pentamine. So cobalt 3 is there. So CO, NH3 whole 5 and 1 chlorine, bracket close, and there we have chlorine. So see how many chloride will come over here? Cl2 will come over here, because this is positive 3, this is having a charge of positive 3, this is -1 +2 and -2 will be over there with 2 Cl negative. That's your 3 marks question. I have done it like this. Sir, there is a valence bond theory, right? Why are we splitting? Valence bond theory contains so many assumptions, and valence bond theory has not been accepted as a final theory, as a very genuine theory. Valence bond theory has so many disadvantages and limitations. Even valence bond theory doesn't account for weak field and strong field ligand, and that's why I introduced this part, because even in the question it was not mentioned. I just introduced it by my own. Even if you solve it with VBT, you will be getting 100% of your marks, because the question is not been asked upon according to VBT or according to CFT. You can apply either of the way, you will be getting full marks. Next question. Calculate the spin magnetic moment for C3 plus ion. So I can solve it with you as well. Number 1. Cerium has an atomic number of 58. And this is the first lanthanide we have after La positive. La 3 plus. Okay. So La 3 plus has 0 unpaired electron. C has 1 unpaired electron. The configuration of C is, I remember the configuration is argon, 4s 2, 3d1, 4s, not 4s, it is 5. This is not argon, this is actually not even krypton. See, xenon, 6s 2, 4f1, 5f1, 5d1. This is the electronic configuration. So if I go for C3 plus, valence electrons will be removed. Valence is this, 2 electrons are removed here, 6s0. Then from 5d0 and 4f1 is there, number of unpaired electron is 1. It is asking of the magnetic moment. Mu will be what? Root of 1 into 1 plus 2 Bohr magneton under root of 3 is equals to 1.732. 1.732 Bohr magneton is the correct answer. Can you check the correct answer, guys? A we have 1.732 is the answer, which is already given over here. I brought it so that I can save your time. I don't want to waste your time because it's a long day you have, and right after the completion of this particular lecture you will not require to do any further practice. That I personally find it from my end. You need to just revise these questions properly 1 or 2 times. You can also solve some of more questions that you have already made it for you, and I think that's enough for the day. Okay, we had this question. The another question asked is, why is copper regarded as a transition element although it has a D10 configuration? But what is a defined transition element properly? A transition element is a metal or an element that contains unpaired d electrons, in its ground state or in its excited state or in any of its state, right? So copper in its positive 2 oxidation state, contains D9 and one unpaired electron. That's why this has been accepted as a transition metal. Now, why scandium 3+ is colorless? Because where Ti3+ is colored, so you will identify scandium 3+ as an electronic configuration of argon 4s0 3d0, and you will explain it has no unpaired electron, and that's why no transition takes place of the electron, and it makes it colorless. While in Ti3+ you will see scandium, titanium, vanadium, there are 2 unpaired electrons. Scandium, titanium 2, scandium, titanium, vanadium, there will be 2 unpaired electron. I guess 1 unpaired electron is there. It contains 1 unpaired electron. So guys, that is the logic behind the colors over here, that because of the presence of 1 unpaired electron over here, which can do the transition in the visible region and can show you the color. That's what you have to explain. Next question, 3 marks. We have plenty of questions in 3 marks, guys. So please try to solve all the questions with me and try to write down everything we have by your own so that you can become even more comfortable. Okay, you can become more comfortable solving these questions with me. The following reaction was carried out in water. This reaction is carried out in water. Br2 plus 2I negative produces this, which is showing that bromine is more reactive than iodine and displacing iodide from its compound. The initial concentration of I minus was 30 and concentration becomes 10 after 10 minutes is 0.28. Then calculate the rate of disappearance of this. Okay, very easy question. First of all, we have to make sure whether this is balanced or not. So rate of reaction is actually given by those elements or those basically compounds which are having stoichiometry is unity. So this is nothing but the change in the concentration of I2 upon delta T, and this is also equals to, if we talk about 2 things over here, that one is I minus, so this will also be equals to the negative of 1/2 delta of I negative by delta T. If you know this formula very well, if you do not know this formula, you must know it, because this is the most basic part of this chapter I'm doing right now. This delta I minus upon delta T is called as the rate of disappearance with the negative signs, and this is called as the rate of production also. So you can identify the rate of reaction, rate of production also. How you can identify? Check out the concentration. So this is like the initial concentration is, the production of this has been also asked. So this is the rate of reaction, that is minus of half of initially it was 0.30, finally it has become 0.28 minus 0.30 divided by in how many minutes it will take place, 10. So guys, this is how you'll be finding it out. This is 0.2 with a negative sign, it will become positive, and 0.2 by this, so 0.01 mole liter inverse minute inverse. This is actually delta of I2 by delta T. We can also call it the rate of production of I2. If you want to know about the rate of disappearance of I negative, it will be negative of delta of I negative by delta T, which will be equals to cross multiply 2 times of delta of I2 by delta T. 2 times of 0.01 will become 0.02 molar minute inverse. Correct answer, 0.02. So guys, I don't think any of the question is difficult over here. If you know the concept very well, if you have gone through the concept once at least, then you can solve all these questions accordingly and very easily. Next question is write the equations for following reaction. One of them is called as Friedel-Crafts alkylation of anisole. I'll explain these questions. Number one, you know anisole. This is methoxybenzene is called as anisole. This anisole is a activating group, and on reaction with what? I don't know it will give you or not. Friedel-Crafts alkylation of anisole. So this is CH3Cl and this is anhydrous AlCl3. This will give you, this will be producing CH3 positive as an electrophile. This electrophile will attack on ortho and para positions. This is your OCH3. This will be one product which will be minor, plus there will be another product at para position. Major product. This is anisole and this is your paramethyl anisole. Let's see the another reaction given here. The reaction is nitration of phenol with concentrated nitric acid. So nitration of phenol is there. You know what, phenol is very activating in nature. In the concentrated HNO3, all the sites available for the electrophilic substitution will be acquired by nitrite group, NO2, 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 and please mention its name. It is called as picric acid, which is also called as 2,4,6 trinitrophenol. One of the strong acid, one of the stronger acid in terms of organic acid. Okay, this question came in 2021 and 2017 also. So very simple question. I hope all of you can solve this question accordingly. Every one of you can solve this question accordingly. Not so difficult, right? So this is right, guys. You can also share this. Please share this with a friend of yours, okay, so that they can also get the benefit out of this session. And meanwhile, let me check how many of the questions are left. I think plenty are there. We have another question that in E0 Cu to Cu exceptionally it is positive. Why is it exceptionally positive? While we see for other metals it is actually negative. So what is the reason why we are getting Cu2 plus? Okay, and why is there are two questions. Why the reason that Cu2 plus over Cu plus ion? So first, for this I must answer you for second question that the Cu2 plus in aqueous state it is more stable than Cu plus in aqueous state stability, and this is due to higher hydration energy of Cu2 plus ion rather than Cu plus ion. This is the answer of second question. The answer of first question is given over here, that whenever we talk about the electrode potential, the electrode potential is not simply calculated. It contains three things. Number of them, one of them is called as ionization energy. The another thing is called as hydration energy. And number three is called as the this is called as the enthalpy of atomization. All of these energies, in which two things are endothermic processes. These two are endothermic, containing delta H of reaction as greater than 0, and the only exothermic process is hydration energy of this M2 positive ion. Now these two energies are dominant over this exothermic energy or the energy release. That is what it makes this whole process endothermic and not very suitable to form it very easily as a cation. So this doesn't form any cation. In fact, a cation accepts electron and form Cu positive. This is the whole answer mentioned over here. That's how you have to write in order to get complete 3 out of 3 marks. Answer is given here. You can check it out. You can write it very clearly that copper has a high enthalpy of atomization and low enthalpy of hydration, and the high enthalpies of atomization and ionization are dominant over the hydration enthalpy, which makes Cu2 positive. Cu is more stable than Cu2 positive, doesn't get easily converted to Cu2 plus. Now I think we should take a break from here, guys. We should take, okay, after completing 100 we'll take a break. So let's see another, or we'll solve this all 3 marks question and then we'll take a big break there. Okay, identify X and Y in the following reaction. What are the X and Y? Arey yaar, this is a very easy question, man. So you have aniline with you, aniline in presence of NaNO2HCl, or we also call it nitrous acid HNO2, under 0 to 5 degrees Celsius. It forms first of all a diazonium salt N2 positive Cl negative, which when attacked by copper cyanide yields the product called as cyano, or we can benzonitrile is the final product. Okay, so this is the first question we just did. Amino group is ortho-para directing an aromatic electrophilic substitution. Why does aniline on nitration gives meta product? So that I can explain you that although aniline is ortho-para directing in nature, but let's say if we are bringing H positive from concentrated HNO3 plus concentrated H2SO4, first of all it gets converted into, this is actually ortho para directing in nature, because NH2 group attached over there is electron releasing group. Now coming over there, it will be converted into NH3 positive, which is actually meta directing. And why it is meta directing? Because the so formed anilinium ion which you are right now getting is electron withdrawing group, and that is what it makes only meta position available for the electrophilic aromatic substitution. And you should also mention this part, guys, that when aniline is treated with these reagents which have been mentioned over, that will be giving you 3 products: ortho, meta, para. Para will be in the highest yield, around 52%. We have to mention it, around 52%. Meta will also be nearly 48%. I don't know, man, exactly. Maybe this is 50%. This is 48%, and this will become around 2%. Ortho is very low in yield. If you want to get the exactly good yield of ortho product, you have to acylate this product's NH2 so that this doesn't get converted into anilinium ion. That's a very important reaction, by the way, which we are right now dealing. Let me take you to the next question. Quickly. We'll go it quickly. This question asked in 2014, 2018, and it's a 3-mark question, by the way. It's a very good 3-mark question we are right now having. Now you arrange these compounds in increasing order of their boiling point. So guys, always remember that a general order of boiling point I must tell you. Here it can be easily written down as CH3COH will have the highest, CH3CH2OH, and the minimum will be for CH3COCH3. Ketones will have the lowest, and this is also the extent of, it is directly dependent on the extent of hydrogen bonding or intermolecular hydrogen bonding. Please try to mention this concept also, because according to hydrogen bonding or extent of hydrogen bonding, the boiling point should be in order of this. Okay, this is order of the boiling point. Next question, the IUPAC name of this compound. We all know that sir, this compound is basically, for these compound, their common name itself has been considered as IUPAC only. So we can simply write 2 things over here. One is, it is called as salicylaldehyde. Along with that, we can also write it that 2-hydroxy or orthohydroxy or 2-hydroxy benzaldehyde. Both of them can be adapted. Both of them will be getting full out of full marks. So no problem guys, please keep on adding the points. Okay, if you face any kind of doubt, do let me know, and those whoever were asking me doubt, I'll take a ask me anything kind of session right after this lecture, after the end of this session. So once I complete all the questions. Okay, we have the next question, that calculate the number of unpaired electrons in the following gaseous ions. It's another easy question guys, you can check it out. That manganese, you have to explain it very neatly and clearly. Okay, manganese, right over here its atomic number, write down its electronic configuration, argon 4s2 and 3d 5. Then make Mn 3 plus in gaseous state, it will be argon 3d, this will be 4s0, and third electron will be removed from here, it will become 3d4. Mention it like this. I count the number of unpaired electrons, 1 2 3 4. So number of unpaired electrons are 4, and its mu has to be find out, or just number of unpaired electrons have to find out. Okay, you do it same for the chromium also, Cr3 plus also you do the same. I think number of unpaired electron in it will be 3d4 4s2 3. Which of them is most stable in aqueous state and why? So what do you think? Which one of them is more stable? Where is it, man? So guys, this has been given in NCERT itself, that since this Cr2 positive has a stable T2G configuration, stably filled T2G configuration, gaseous ion, so no doubt we can't speak about this, but if we talk about their aqueous state, this will be forming a complex where Cr is supposed to have the half filled in aqueous state. In aqueous state, Cr3 positive is supposed to have this is the as a half filled stable T2G configuration, that makes it more stable than manganese in +3 oxidation state. Let's have another question, and this question is from, I guess, chemical kinetics, and it is another important question, came in 2021 also, and it's a high order thinking question. In this question, concentration versus time has been plotted. This is a decreasing graph, straight line graph. So this can be written as concentration of reactant is equals to, at t time is equals to concentration at 0 time or not minus kT. This is the expression of 0th order reaction. This is the expression of integrated rate law of 0th order. So first answer is done, number one answer is done, that is order. So order will become what? 0. Number 2, it is asking about the slope. The slope will be negative of negative of K. K is actually your rate constant, and negative sign is basically telling us that the slope is negative. The concentration of reactant is decreasing with the time. And third one is, what is the unit of the rate constant of K? The unit will become what? The rate unit is actually unit of K. We have a general formula. as mole liter inverse raised to power 1 minus n second inverse. Your correct answer will be mole liter inverse second inverse. That's it. I think we have completed all these three parts. You will be getting 100% of the marks. 3 marks. We have plenty of questions on 3 marks. Why have I come up with so many questions? Because 3 marks question have been asked in plenty, and there are like 7 3 marks question. Out of these 7 3 marks question, I try to make so many. Let me check. 7 3 marks question are there. So unless we'll be having now only one segment left, rest of them we have already practiced. So we'll take a few more minutes in order to solve out the remaining one. And once the 3 marks question are getting over, then we'll be solving 4 and 5 marks after a small break. I think we were over here. Let's see this question, everyone. Let's see this question. We have so many things over here with us, and the one which is having highest unpaired electron, guys, you must understand what is the number is over there in the magnetic moment. That actually number, this number represents you the number of unpaired electrons. So your correct answer of first question should be chromium 2 positive. 4 unpaired electrons are there. Colorless aqueous solution is formed by scandium because it has 0 unpaired electron, and most stable is also scandium because as it contains a noble gas configuration. As it contains a noble gas configuration of simply argon 18. That's why this is most stable out of all. So we have given all 3 answers in just quickly few seconds. Next is, which vitamin causes a disease called rickets? So rickets is basically deficiency of vitamin D, calcium and phosphorus. If it is phosphate gets reduced in our body, children actually face the some inverted leg or bones, weakening of bone. That is what it comes. Number 2, it's from the vitamin chapter is biomolecule. Name the base that is found in nucleotide. Nucleotide of RNA. Nucleotide of RNA. Base. Uracil? No idea. Oh, uracil is fine. Man, actually, I also haven't studied this chapter from a long time, but I remember the uracil is correct. Uracil is the only thing that is found in RNA and not in DNA. Glucose on reaction with acetic acid gives. This is only found in RNA only, okay, not in DNA. Glucose on reaction with acetic acid gives glucose pentacetate. What does it suggest? It suggests you that there are 5 hydroxyl groups which are reacting with these 5 acetate groups, acetic acid, and producing acetates. So I think this is correct. This is the answer, vitamin D, uracil and 5 hydroxy groups. Even if you mention like this, you will be getting 100%, 3 out of 3. Rest you can also do it. Improvise your answer, okay? Not a problem. Let's come to the another question. IUPAC name of the product formed when? Number 1 is 2-methyl-1-bromopentane is treated with the sodium in presence of dry ether. First of all, let's make it. It's bromopropane. So meth, eth, prop. And the middle one is connected with a methyl. One is connected with bromo, CH2Br, and this is one compound. So you know this reaction, we will be using 2 equivalents of this compound, and we also use sodium, 2 sodium, and we use dry ether as a medium, and then Wurtz reaction will take place, forming CH3, CH3CH, CH2 will be connected to the similar group. This is the product formed over here. Need to write the name 1, 2, 3, 4, 5 and 6. So we will be having 2,5 dimethyl hexane. This is the answer actually. This is your first question. You can also mention this reaction, Wurtz reaction. Number 2, 1-methyl cyclohexane treated with HI, 1-methyl cyclohexene. So we have 1-methyl cyclohexene like this, and this has been treated with HI. So guys, Markovnikov's addition will take place. More stable carbocation will give you the final product. You have to put iodine over here and hydrogen will be connected over there. This is your correct answer. Please name this reaction, name it properly. What is this compound formed? So you have to name it from here only. 1, 2, 3, 4, 5 and 6. So this is iodo or methyl. 1 iodo will come first. 1 iodo, 1 methyl. Alphabetically we are going, okay? Cyclohexane. And third is chloroethane is treated with silver nitrate. Chloroethane is treated with silver nitrite, AgNO2. You know what AgNO2? This reaction is SN2. It will give you CH3. One step reaction will take place. And ONO will be connected over here. No, I think NO2 will be connected. Please remember this reaction. If it would have been KNO2, in that case of KNO2, it would have given you ONO, nitride, but it is simply nitro compound. Okay? That was the third question we had. That's it. So let's have the another question. Another question is, a metal is M positive, Mn positive, having D4 valence electronic configuration. It combines with a 3 bidentate ligand. 3 bidentate ligand means it is forming an octahedral complex. Okay. Number 1, electronic configuration of D4. So first of all, this is D4, and assuming that delta is more than pairing is actually lesser than this, then definitely it's a weak field ligand. No, it's a strong field ligand. How we are deciding it's a strong field ligand? Because delta is more than pairing, so pairing will occur there. So how we will fill it? This is EG, this is T2G, 1, 2, 3, fourth will be paired up because it's a high gap over there. This gap of delta O is even greater than the pairing given in the question. So basically this is because of the strong field ligand, and your answer will be, the configuration will be, you'll be having T2G 4 EG0. Next question please. What type of hybridization M positive make? These are available. D2sp3. Simply write it. No need to extra elaborate. Name the type of isomerism exhibited. So basically, first of all, we have to think what kind of complex is it making. Okay, I think this will give you optical isomerism. You can show by making this compound. This is metal N plus. Let's say this is En is the this bidentate ligand. This is actually the syn form. Cis actually I'm talking about, but no cis trans is not occurring there. It's a simple compound which will be giving you Mn plus. This is the correct answer. Okay, D plus L. This is how you can actually mention all the concepts involved in it. You can get full out of full marks as well, and this will give you 3 out of 3 marks here. That was another 3-mark question we had. Okay, we gave another question, by the way. Which one of the following is a disaccharide? So guys, I not need to mention it, you already know about it. Starch is polysaccharide, maltose is disaccharide, fructose is the correct answer. Monosaccharide, actually disaccharide was asked, maltose is the correct answer, and not glucose. Glucose is mono, and so maltose is correct. So the first question. Difference between fibrous and globular protein, you just write 2 or 3, it is fine. That fibrous are the long and narrow, and globular are the spherical in shape and round in shape. Their strength and support, and they anyways we can simply write that they are mostly soluble in water, fibrous one, and they are insoluble. Fibrous one are insoluble in water. Their examples are like keratin found in hairs, collagen. We have globular protein examples such as hemoglobin, insulin, catalase, okay, and even that's it. So please read it out once. Write the name of the vitamin whose deficiency caused the bone deformities I was just discussing about. It is vitamin D, and this causes its deficiency. Its deficiency causes rickets. Next question. Why propane is less reactive than ethanol? So guys, please mention it here. This is a very easy question. There are two reasons. One of them is steric reason, and but just elaborate it once. And another one is electronic effect, that with more plus I effect on propanone, it will be less reactive than ethanol. This compound has a lower pK value than this because, just explain this part, that right after removal of one OH group, and we have गल सुन लहरियां वे लोग में रहते हंस दे ऐसे सामने जी फोटो दे फरारी ला दी चुनी मेरी रंग ते ले This causes negative inductive effect, makes it more stable. Since this is more stable, this will be more acidic in nature. The counter ion, or we can simply say that the conjugate base is more stable, that makes this nitroacetic acid as more acidic in nature. And third one is CHO undergo aldehyde condensation while other does not. So C option, C, the question number C. There is one that has one hydrogen, CH2, okay, we have C double bond OH, this is CH3, this is another CH3. This is actually, this is your alpha carbon. So because this has alpha hydrogen, which is required for the aldol condensation, while this CH3, CHO, this is alpha, no alpha hydrogen, no aldol condensation, simply like that. You can mention it and no need to explain the whole reaction mechanism, that this will go undergo this reaction, this will undergo this reaction. No need to take that into account, but simply you can take their example and then you can move forward. Yeah, so many questions are here, man. Let's see another question. A non-reducing disaccharide A. Non-reducing means it is definitely a disaccharide. Oh, the only non-reducing disaccharide is sucrose. Okay, the only non-reducing disaccharide is sucrose. So sucrose undergoes hydrolysis, giving you alpha D glucose and beta D fructose. So identify A. So A is sucrose, first done. Then what is the mixture of D positive, and this mixture is called as inverted sugar. Mixture name is called as inverted sugar. Please write it carefully and try to explain it. And then name of the linkage. So there is basically C1C2 glycosidic linkage. C1C2 glycosidic linkage. This is completely done now. A part. Let's see B part. Alpha amino acid have higher melting point than alpha halo. So this is alpha amino acid, CH, this is NH2, this is some R group, and this is COH group. So you will find that they have higher extent of H bonding, higher intermolecular not intermolecular hydrogen bonding. That means with other molecules they have a higher extent of H bonding rather than if we are connecting Cl over here. Cl will not do any kind of H bonding. So that is why this. So this is the order of boiling oblique melting point. Another question is here that a compound following are to you, and we have to basically write the compound which is most reactive toward SN2 out of these also. 2-bromopentane. Let me first write the structure. You do it properly, okay? 2-bromopentane. This is 2-bromopentane. 2-bromo-2-methyl. Two bromo 2-methyl. Add 1 bromo. So guys, if you want to ask me that this is A, this is B, this is C. So now I can simply reply, what is the compound that will be giving you most reactive toward SN2, which is 1 degree. Where is 1 degree? C. The compound which will be optically active, where can you find yeah, this is the chiral carbon. So A is the correct answer here. And write the compound which is most reactive toward beta elimination. So the beta elimination takes place 3 degree, 2 degree, 1 degree. Beta elimination takes place 3 degree, 2 degree, 1 degree. So where can we have 3 degree, 2 degree, 1 degree? This is 2 degree. This is 3 degree. I think B is the correct answer. Check out this answer. CBE, CAB, CAB. CAB is the correct answer. CAB is the correct answer. निम्नलिखित अभिक्रियाओं के उत्पादों को लिखिए. So guys, you got to find out the products. Simply find the products. So if you attack it over there, this will give you, it will become OH, it will become cyanohydrin is the product. You please name them also so that it will be better to write it down. This is cyanide carbonitrile. So we can write it like, which comes at top. Carbonitrile I think comes at top. So 1 hydroxy cyclohexane 1 carbonitrile. That's the name of this compound. This is the soda lime decarboxylation reaction. It will be simply eliminated out, and benzene is the correct answer. And third one, diable H and water. It gives you selective reduction of cyanide converting into CH2OH. CH2OH or what? CH2NH2. चुन्नी मेरी रंग दे ललारियां ने यार ते गड्डी दे नाल दी ओंजली ते नोंजली होने कर दी गड्डी दे नाल दी. CH2NH2. Next question, 3 marks question. Right now we are doing, we have plenty of question in 3 marks. Okay, that's why it is taking too much time. That's why it is taking us too much time, because we have plenty of questions in 3 marks. Okay, we'll try to do this question and then we'll take a break and then we'll connect back soon. So then the following compounds are given to us. I think this is completely done, guys. I think this has been done. Let's say this is A, this is B, and this is C. So the correct answer will be C over here. Optically active is actually A, and this will be B. From here we'll start it, but now let me take you. So guys, we have a very important, let's say this is over here, no? So guys, I would like to request you just that we are celebrating, the Unacademy is bringing one very big like the biggest educational festive on which we all educators are getting together, and that is the only day that comes in the whole year and where we all meet, and not just with together, we also meet with the influencers. So many good, in fact comedians are coming, very popular celebrities will be over there, and you will find a lots of motivation watching this video, watching this live session held by us. So guys, please go on J in Access by Unacademy. This is the video I'm actually looking you for. So go there and click on notify me. Click on the notify me button. Click to notify me. Okay, and now we are having a proper break, which right after that we'll connect together and we'll solve the remaining number of question. Okay. Hi guys, so I'm back, everybody. Hopefully we all had an amazing break. Actually, the session was already amazing. Now I'll take you directly to, okay, hopefully you all have clicked on the notify me button, and you'll be watching the celebration and the festival that we are bringing, Unacademy Aram 2025. Coming back to our questions, are not questions, yeah. Where are the questions? अरे यार क्या हो गया इसको यार, फाइनली I was just checking out, guys, how many questions have we solved till now. So over some 50 questions we already have solved, and we already have completed the segment in which we covered all single choice question, all assertion reason based questions, and then thirdly we solved all 2 marks question. We were in mid of finishing all 3 marks question, and right now the next question with us is this. That was some repeated question. This is the next question, and which polysaccharide component of carbohydrate is presently commonly present in bread? Okay, I would expect you people to answer me, respond me in the comment section. So guys, the answer is very simple. This is starch actually, which is present in bread, rice, pulses, and even in potato. So that's how we have to basically write the answer, that the main polysaccharide present in the bread is starch, and which is also found in wheat made. No need to write extra, just simply write it this line, that's it. Write 2 types of secondary structure of protein. One of them is called as alpha helical structure, another one is called as beta plated sheets. Third, give 2 examples of the water soluble vitamin. Water soluble vitamins are actually your globular proteins. So globular proteins you can pick the example for. Enzymes are also one of them. Water soluble protein containing albumin, like casein, myoglobin, and ovalbumin. That's it. Next 3 marks question is here. Identify A and B in the given sequence of the reaction. So that is what I can do with you. We have A question. We have phenol on reaction with NaOH and CO2 under acidic treatment forms orthosalicylic acid. Orthosalicylic acid on reaction with acetic anhydride produces acetic acid, will be removed out, and this gives you OCOCH3, also called as aspirin or orthoacetoxybenzoic acid. This is your product. First you got to identify A, and then you have to identify B. Next reaction is B. A compound is there that on mild oxidation, mild oxidation gives you CH3CH. So this compound will be CH3CH2OH, which upon oxidation with PCC, this is actually compound A, produces CH3CHO. A further reaction with I2 and NaOH gives you CHI3 iodoform plus CH3 HCO negative, Na plus. So this is what we get from this reaction. This has been oxidized. This CH3 is converted into CHI3 iodoform reaction. So your compound, this is already given. So B actually is your iodoform. B, yellow color PPT iodoform precipitate. So you got to write down reactions like this. Okay. Hopefully you all are fine with this, how to write the answers. This is what your question was about. Around 55, 56 questions we have done it till now. And this question is from 3 marks question right now we are having. Okay. Now there is one more question. I think 4 options have been given up to us, but we'll see. Out of COFX in CON whole thrice, the complex is paramagnetic. More actually, this is very easy. You can simply pick over here like this. That's COF6 3 negative. Cobalt is a 3 positive over here with a weak field ligand. So with a weak field ligand, you have to fill it the configuration in this way. Then COEN whole thrice, which is a strong field ligand, and CO3 plus in presence of strong field ligand, we have to fill it. So basically 3d6 is there. 3d6 will be filled over here like this. Over here 1, 2, 3, 4, 5 and 6. So which one of the complex is paramagnetic? Which of the complex do you find is paramagnetic, guys? Where can you find the unpaired electron? The paramagnetic will be CO F6 3 negative, which is more stable. A more stable will be having CO and same actually strong field ligand forms stable complexes. Also En over there is a chelate ligand. It is a chelate ligand. It will form a chelation, a ring structure, which is more stable than the open ligands like this, monodated ligands. So it will become COEN whole thrice 3 positive. Then we have inner orbital complex. Where you get the inner orbital complex? So as you see that we can also write the hybridization here. All of them are available, so it will form you outer orbital complex sp3d2. And this will give you d2 sp3, sp3d2 and d2 sp3. Inner orbital complexes d2 sp3, which is CO En whole thrice 3 plus, and high spin complex with higher number of electrons present to spin, which is over here. This will be CO F6 3 negative. I think 1, 2, 3, 4 all we have completed. Now let it be a question of case study, let it be a question of 4 mark, let it be a question 3 mark. We have already solved it. That's it. Let's come to the another question. What happens if D-glucose? So beta D-glucose with its gigantic structure, 6 carbon atoms, combines with HI, gets reduced on heating and produces you a straight chain of C6H14 called as N-hexane, and that also gives an idea about the straight chain complex or straight chain compound of glucose structure. Okay, then concentrated HNO3, it will basically convert the CHO group as an oxidizing agent. CHO will be converted to COH, and even the terminal CH2H will be converted to COH. The structure so formed is called as what we call it, glucaric acid or saccharic acid. Both of them are the same. And what structural difference between starch and cellulose? So cellulose and starch are different on the basis of alpha D-glucose and beta D-glucose. So cellulose contains beta D-glucose, starch contains alpha D-glucose in the monomeric unit. This is the difference, and these are the products that will be formed: saccharic acid and with HI introduction N-hexane, straight chain hexane. All clear, guys? Well, thank you, Mr. Home Foods. Is there an English batch? Probably the English batch will be coming very soon, guys. Don't worry. Okay, I'll basically refer this feedback to the hire team so that they can arrange some batches, some paid batches also. Let's come to the next question from here. There is a next question, and this is a 3-mark question absolutely, because this is an application of mathematical formula called as what we call is Nernst equation. Calculate EMF and delta G. So first of all, what we'll be doing, we have to apply Nernst equation. Applying Nernst equation. We have E cell, E naught cell minus 0.059, or simply write 0.06 by n number of electron transfer. You can also write down the complete reaction, where you can get the idea where what has been used. Magnesium on reaction with copper 2 plus aqueous produces magnesium 2 plus aqueous plus copper has deposited here. How many electrons have been transferred? 0 to plus 2 and plus 2 to 0. 2 electrons have been transferred. So write 2 over here. Logarithm of, we have concentration of magnesium here, concentration of Cu, 2 plus in the denominator. So E cell will be what? 2.7 minus 0.03 logarithm of Mg2 positive is 10 to the power minus 3 upon 10 to the power minus 4. This will be 10 to the power positive 1 over here. Right, guys? Okay, this is minus 1 left down. So this will be coming up as positive 1. Overall left is 1 by 10 to the power positive 1 will be left over here. Hopefully I'm doing it right. Absolutely I'm doing it right. Then it will become 2.7 minus 0.03 into logarithm of 10 is 1. So after removing 0.0, it will become 2.67 volts. Now once you get to know about the E cell, you can also identify delta G. Delta G will be NF E cell. Delta G will be N. How many number of electrons have been transferred? 2. What is the value of F96500? How much is the E cell? We got 2.67. Guys, just simply do the multiplication and please find out this value, and to your final answer put a joule over there. That is the correct answer. So simply. That's it. Now we'll move to the next question from here. That account for the equations of the reactions involved. What is the meaning of account? I don't know. So we have to basically explain the reactions here. That Gabriel thalamide synthesis is preferred for the preparation of primary amines. So why does it happen? That we have to basically explain. So let me explain you why does it happen. So how does this reaction take place? First of all, let us know about that. Gabriel thalamide synthesis reaction is usually preferred to prepare 1 degree amines only, not even for secondary amines. The reaction mechanism simply says that Gabriel thalamide synthesis is GTS reaction. We have a compound called as thalamide. This is called as thalamide. We are allowing this thalamide to be reacted with base KOH, where this compound becomes potassium thalamide, a salt. A salt then further reacts on primary amine, primary halide RX. When this R being attacked, X gets eliminated out. This is a SN2 reaction. The so formed product will be your N-alkyl thalamide. This is called as N-alkyl thalamide, NR. Now if you further carry out the reaction and keeps on adding H2O, or let's say water, or if we say base over there, whatever you pick there, then the reaction takes place 2 times, and we get final product this as COH or O negative. Finally we can make it out of this, and this will be converted into RNH2. This is your 1 degree amine. So this is only 1 degree amine can be synthesized under this reaction. That's what you have to mention. But again, always clearly mention what compound you are using and what's the name of this. So like this is your phthalimide. Phthalimide. This is called as potassium phthalimide. This called as N-alkyl phthalimide. And then finally we get 1 degree amine with phthalic acid. This is called as phthalic acid. This is the whole reaction that we had to make Gabriel phthalate synthesis, that how we only get the primary amines. Now next is methanamine and aniline. So guys, if we explain the second part, we have been given up with 2 things. One of them is methanamine versus aniline. And it has been given that its Kb, in fact pKb is 3.38 and 9.38. If we consider both of them, then we will come to know that which is more basic. Actually this is being more basic, and this compound is actually less basic. And the compound which is less basic, which is aniline, is less basic because of its lone pair is not easily available to be donated to a proton, and these resonating structures are showing the lesser density of electron or the negatively charged lone pair. These are lone pair over there, and that's why using these resonating structures we can show that the lone pair present on nitrogen is not just on nitrogen, but it is basically divided on these positions. And since electron density on nitrogen decreases, aniline becomes less basic than methanamine. That is the correct answer. So that's how you have to explain everything by writing. Okay, this question is actually a 3 mark, and you got to explain every aspect. Okay, there were 2 options asked, 2 questions asked in this question, and it could be like 1 plus 2 kind of question, or 2 plus 1 kind of question, or 1.5 plus 1.5 kind of question as well, let's say. So there was a 3 mark question which we have just done it. Here is the explanation given for this, but not required, we already have made it. Let's come to the another question. Again, another 3 mark question we have. 3 mark question we have. Number 1. Write the correct formula using the coordination compound. It gives you 3 chloride ion precipitated as AgCl, 3 chloride ion precipitated. That means the first compound will be Cr, H2O whole 6 H2O will be inside of the complex, only Cl3 will be outside, which will be undergoing reaction with aqueous AgNO3 forming 3 moles of AgCl. Let's look at the another question. 2 chloride ion are precipitated as AgCl. If 2 are precipitated, this will become Cr, H2O whole 5, 1 Cl and 2 Cl2 will remain outside, so that 2 chloride ion can be precipitated as AgCl. The third example is 1 chloride ion is precipitated, so this is Cr, H2O whole 4, actually we have to pick here, and we have to keep 2 chloride here and 1 Cl will come outside, and that is how we write the correct answers. Next question, please. Predict the major product of the acid catalyzed dehydration of 1-methyl cyclohexanol. A. Predict the major product of the acid catalyzed dehydration of 1-methyl cyclohexanol. First of all, let me make this compound. 1-methyl cyclohexanol. Okay, like that. So it's very easy reaction. By the way, predict the major product only you have to predict. Don't write down the mechanism as such. We are also have been given with the concentrated H2SO4. So this is reaction is called as even elimination reaction, and dehydration of alcohol is the actual name of this reaction. And this is how the most stable alkene will be there as a major product. There could be another possibility also, which is this endocyclic. This is endocyclic inside, and this is exocyclic outside of the cycle. There is a double bond. This will be a minor product. Major versus minor. B. So we got to predict the product. This is our product. What is the name of this product? This is called as 1-methyl cyclohexanone or cyclohexene. B. You are given with benzene and concentrated H2SO4 and NaOH and HCl. What is the preparation of phenol? So I'll prepare it, no problem. I'll first of all use concentrated H2SO4. This reaction is called as sulfonation of benzene. A sulfonated product SO3H will be formed, which once treated with NaOH and heated will give you phenol as a product, or O minus Na plus as a product, and H2SO4 will be eliminated out, H2SO3 will be eliminated out. Then you add HCl over there. Dilute HCl will make this compound as phenol. This is how the reaction will go. This option reaction A, this is reaction B. You will get 100%, 3 marks out of 3 marks. Okay, if you do like this, you will be getting 3 marks out of 3 marks like this. That was another question, also 3-mark question. Let's see another 3-mark question. I think we have done some more than 20 3-mark question till now. Yeah, so many 3-mark questions are going on. But actually, what we can do, there are actually plenty of questions which are asked on 3 marks. So we have to do it, no doubt. Let's see another question. We have alcohols are more soluble in water than hydrocarbons of comparable mass. So number 1, I'll write them shortly. You can explain it. Due to intermolecular hydrogen bonding between alcohol and water molecules, which is absent in terms of hydrocarbons. Okay, we have that orthonitrophenol is more acidic than orthomethoxyphenol. Orthonitro. Okay. So see, this is orthonitrophenol and this is orthomethoxyphenol. methoxyphenol. So let us suppose if we are removing one hydrogen or proton out of them, so this compound will be O negative with NO2 group over here, not over here on ortho position. So this ortho present NO2 does negative M effect more than minus I effect, and so that it stabilizes. This is actually stable. But over here, this is O negative, here is OCH3, which does positive M effect more than minus I, and due to which it is unstable. So the correct answer is, which should be more, the conjugate ion should be more stable, then we can call them acid as more acidic. So this is actually the order of Ka, acidic strength. This is your second question. Let's see the third question. Why cumene is a better starting material? Because cumene, which is also called as isopropyl benzene, cumene is also called as isopropyl benzene, under atmospheric oxygen gets oxidized to prepare cumene hydroperoxide, and that under reaction with water under acidic condition produces phenol and acetone. So that is how this reaction works. 1, 2 and 3. Now that was very fantastic question we had for 3 marks, just to give the identity, just to give the explanations behind the logics. I have already done it in a simpler way and very straightforward way, but I am pretty much sure that nobody can deduct my marks, and that what's a confidence we should have always in giving the answers, because it should be to the point rather than unnecessarily writing so many things. Okay, it doesn't make any sense. Now we'll come and try to see another question. Now we have to show that in case of first order reaction, the time taken for 99.99% of the reaction is 10 times the time required for 50%. So first we'll find out the time for 50%. We know that there's a formula. This is equals to ln2 by k. We can also derive this, but I don't think that's required. We can simply identify ln T50 is ln2 by k. If we know this, then we can directly identify the T of 99.9%. Always make sure that if writing, you can also make sure writing this thing, that reactant undergoing reaction and producing product, T is equals to 0. This is, let's say, A naught. This is 0. T is equals to T 50%. Half of this will be rejected. A naught by 2. This will be also A naught by 2. Okay. At T is equals to 99.99%. 99.9%. So this is like 0.1%. This will be, left amount will be 100 minus 99.9. This is 0.1 upon 100. So 10 to the power minus 3 A naught will be left, and this is like 99.9 A naught formed. 99.9 by 100 A naught formed. So now apply T 99, but this will be ln2 like so 2.303, or we can simply take ln, and here will be k, which is ln2, and k will go above like this, not like that, yeah. So here, from here we can get k is equals to, okay, that is how we can also solve it. Let's solve it in this way only. So T 99.99% will be ln of A naught by A by k, and this will be A naught by A. A naught is how much? A naught, and this is actually 0.00 A naught. Actually this is not coming 10 times. I can see it's coming like, Okay, yeah. Probably this is coming like 10 times only. So this is 0.001 A naught. So it will be like 10 to the power 3 over there. So T 99.9% is exactly coming up as ln of 10 to the power 3 by K. Now if we compare these two, I don't find it's a correct answer, by the way. Let's say if it was 99% only. So that's how finally we can apply that T 99.9% upon T 50%. 99.99% we already have found out. Ln of or 3 ln 10 by K upon ln 2 by K. K will be cancelled out. 3 ln 10 by ln 2 is here. Is it 10 times? No idea on that. We can also take it log 2 like that. Okay, I think we are right. This is 3 times of like we can also take it 3 into 2.303 logarithm of 10 upon 2.303 logarithm of 2. So 3 times log is 1 and log 2 is 0.3. This is 0.3. We'll solve it, we'll find 10 times. So 10 is correct answer. By the way, this is what we have proved it. Okay, so we first have started from here. First you need to do this, second we have to do this, and that is the third part. We have to do this. So that's it. That was a good question, by the way, we had, and this question is very much repeated question, so there is a huge possibility that this question can be asked in your exam. Now I'll take you to the next question from here. There is a question that says that we have to distinguish between these two components. Where is A? Our only directly came to B. Okay, let's take them two together. One of two, these two have to discuss. These two have to be distinguished. What tests are there that you can distinguish between these given number of compound? So let's say this is B. First is benzene COCH3, and it contains a methyl keto group. If you react it with I2 and NaOH, sometimes this can be reacted with NaOI, then the product will be an oxidized product, and with one CO negative Na plus with CHI3, yellow PPT, iodoform is formed. But if I carry out the same reaction with CHO, no reaction. So right, in the similar way, these two compounds, out of these two compounds, if I react HCOH with Tollens reagent, which is AgNO3, NH4OH, silver nitrate, ammonical silver nitrate solution, it oxidizes it and it forms it CO2, and with silver deposited over here, or there could be silver deposited over here. We can also do the Benedict's test or Fehling solution test, applying Cu2O. Then it gets converted into CO2 gas, and this CuO will be deposited over there. This is oxidized, this will be reduced actually. So this is CuO actually, cupric oxide, and produces Cu2O, which is a red PPT. This is called as the Fehling's test we are going. Fehling's test is positive for this compound, but if I do the same test for CH3COH, no reaction. So we have distinguished between these two, right? This is done. Now let's see, check it out, this question. Their boiling points will be, so we know that alcohols have carboxylic acid have highest extent of H bonding, that's why they will be having higher boiling point, followed by alcohol, and then followed by CH3CHO. This is the boiling point. This is the boiling point. This is also the extent of hydrogen bonding between these molecules, right? All well, all set. This is a 3-mark question. You will get 3 out of 3. If you can write the whatever I have mentioned here, if you can write all possible things, then you will be getting full out of full marks, 3 out of 3. Let's see one more question leading to 3 out of 3. Which is the most common oxidation state in lanthanide? No need to mention anything else, simply mention Ln3+, and simply let them know that oxidation state is positive 3. So this is the most stable ion. They all wants to go to positive 3 oxidation state. So oxidation state is positive 3. And why there is a gradual degradation in the atomic size, which is also called as the lanthanide contraction? Simply say that poor shielding, if we keep on increasing electrons, then poor shielding of d subshell takes place. D orbitals have poor shielding, due to which size keeps on decreasing, because Z effective keeps on increasing and electronic repulsion shielding keeps on decreasing. That's how it works. Third, calculate the number of unpaired electron between the following, so which is very simple. Vanadium has atomic number 22, scandium, no, 23, scandium, titanium, vanadium. Correct answer should be argon. 4s0, 3d3, so 3d2, 4s0. Number of unpaired electrons are 2 over there. Now if I write it for titanium 3+, scandium, titanium, so this is argon, 4s0, 3d, 2 urban electron, 1 more electron, 3d1, scandium, titanium. Number of unpaired electron is 1. Completed. All 3 are completed. And this question came in 2022, 18, 16, 12. We have just made it, dude. We have just made it, guys. So that's how we have to basically approach to these questions. That's how we have to approach to these questions. Sir, where are you from? Actually, I'm from Bengaluru, guys. These days, nowadays, I'm teaching you from Bengaluru. हाँ, बोल गौतम. Yes, yes, class में हूँ, बोल. ठीक है, मैं फ्री होकर कॉल करता हूँ. Come back. So that was a question we had of 3 marks. Hopefully you all have got the question. Now let me take you to the next question of the day, guys. Oh my god, this is a high order thinking question, and this is like 2022, 2019, 17, 15. It has been repeatedly asked. So let's see how can we solve this question. This question is NaBH4 is given. We know NaBH4 doesn't touch this group. This is an ester group, and this is a ketone group. Only ketone will be reduced to hydroxyl group, which is hydroxide. This compound will remain exactly like this. Next, CH3 with a negative charge, Mg with a positive charge. अरे क्या है यार? CH3 goes there, attack over there, forms CH3, C double bond O, no, CH2OH, CH3 CH2OH will be the final product, directly finding the product only. In the third case also, hydration is done over there, and this is called as acid catalyzed hydration, follows Markovnikov's addition with a small stable carbocations. That's the OH will be connected over here. More number of hydrogen will acquire more number of hydrogen. That's how it has to work. This will acquire hydrogen, already higher hydrogen number of their hydrogen will be there. This is what the products are. You can also write down their names as if it had been asked, but I don't think it's been asked. Actually, it's asking the structure of the product formed, only had to write structures are here. It will give you exactly 3 out of 3 marks. You don't need to do any further hard work for this. Okay, just move forward. So now we have the hydrolysis of sucrose is represented by a chemical equation, a question that came in 2019. It's a 3-mark question. So in this reaction, one molecule of this is attacked by one molecule of hydrogen, water. So 1 plus 1 molecule, the molecularity will definitely be 2. It's a bimolecular reaction. But even though the molecularity is 2 and one of the component is in excess, so that its concentration doesn't basically decide the rate of reaction, the order of the reaction will become 1. And because this reaction is called as what? Pseudo first order reaction. When one of the component is given in excess amount, then other will decide the rate of reaction. The rate of reaction in terms of all reactant and product will be written up as rate is equals to rate constant K into concentration of C12H22O11 raised to the power 1, because this is called as the pseudo first order reaction. That's it. Wow, yaar, yes, you're right, I guess. Silicon Valley, wow. Hopefully you all are up to the same page. I have solved plenty of questions today. Now some of the remaining questions will also be solved very soon. What is the effect of pH? So let me explain you that. Simply write it in this way, that this is Cr2 O72 negative, that is converted in basic medium to Cr2, yes, Cr O42 minus, called as chromatin, and this under acidic condition chromatin gives you dichromatin. So this is basically dichromate, and this is chromatin. If we talk about their color, dichromatin is orange in color and chromatins are yellow in color. Also give the structure of dichromatin along with color of the species. Structure of chromatin dichromatin. The structure will be, this is dichromatin Cr O Cr 1 2 3 K2Cr2O7. So Cr2O7 like that if to went down the structure. So this has been O negative, and this will also become O negative. If you add K there, then it will become this. Okay, this is orange in color, and the yellow one is chromatin. How does it look like? O negative, double bond O negative. This is chromatin. sp3 hybridized. Both of them are D3s and tetrahedral geometry. This whole thing can also be elaborated a bit more. I have written down everything in to make it short and simple, because we have plenty of other questions also to solve with. That's why I have come up over here with this. But you can do it by your own. You can also explain every single part in it. Now, okay, this has been given as the answer, which we have already done. Let's move forward. complete the chemical reactions like this. Okay, so guys, I don't think there's a requirement of balanced chemical reaction over here, because this is not asking all the balanced chemical reaction, but we must know what reaction will take place. This is a double displacement reaction. It's a simple reaction. It will form NaCl plus this will be converted into K2Cr2O7 2, and this will be 2. This is a balanced chemical reaction. In this reaction, the sulfide ion will be converted into permanganate ion itself will get converted into Mn2 plus. Sulfide ion will be converted into sulfate ion. That's it. And you can also do the redox reaction wala part to make this reaction balanced, but I think we are done up to here. No need to balance until unless it is mentioned. Okay, but if you want to get, or if you don't want to get into confusion, you want to go for the maximum marks, I think you can balance it also. And how does the color of C2 changes with an alkaline medium? I told you that Cr2O7 is orange colored crystals. These are orange colored solution that upon treatment in basic medium converts into Cr2 CrO4 2 negative, which is actually yellow colored. If you do the same reaction in reverse in acidic medium, this will be reversed also. That's how this works. That's it guys, we have completed, I guess, all 3 marks problems here, all 3 marks problems until here, or not? No yaar, something is always remaining here. Glucose with HCN, cyanohydrin. Bromine, light level of oxidation will give you gluconic acid, and then with HI reduction, straight chain will be given to you, that is C6H14 called as N-hexane. But again, there is the reaction given to all of you, no need to worry. Cyanide will attack over here, make it cyanohydrin, number 1 reaction. Reduction with HI and heat will give you N-hexane, and oxidation with bromine water, a light level oxidation take place, only this will be converted to CH called as gluconic acid. If we are using concentrated HNO3, then both of these parts will be converted into COH. This becomes glucaric acid or saccharic acid. Easy questions, yeah. Many times repeated question. It's a many time repeated question. Let's see another question. So give some simple reason why electrophilic substitution in haloarine occurs slowly. So you can mention so many reasons. Number one, that due to electrophilic substitution in haloarenes occurs slowly. Electrophilic substitution due to negative eye effect of halogens, because halogen generally do what? Negative eye effect dominant over positive M. That's why the rate of reaction is slow, right? Number 2, sulfuric acid is not used during the alcohol with Ki. So basically this Ki reacts with H2SO4 and gets converted into, this is an oxidizing agent, gets converted into I2. So simply there's no reaction in that way, but usually if we treat alcohol with HI, it gets converted to Ri plus water. This is what we wanted to produce as Ri. But if it is oxidized to I2, the reaction will not occur. This is what you have to write it in your own language, but more clearly. I might have not submitted the clear answer because we have done plenty of things, and I'm not very much comfortable writing so many things. Alkyl halide give nitrite while KCN gives isonitrite. Why with AgCN? Because we'll mention this thing that when we react Rx with K plus and Cn negative, then cyanide attacks there and RCN is the product along with Kx. Right, because this is an ionic compound. KCN being an ionic compound contains a negatively charged ion called as cyanide ion. That's why cyanide ion is attacking there. But if I carry out the same reaction with AgCN, there is a covalent bond between carbon and Cn. Now nitrogen goes there, attacking here in this one step. This is the covalent compound which contains a covalent bond between silver and carbon, and this is the final product. We'll be getting RNC plus AgX. So this is your isocyanide, this is cyanide. Hopefully all of these are completed now. I have covered all of these. Next reactions. So next reactions are pretty simple, guys. You already have seen these reactions. One of them is carbylamine reaction. So every alkyl and aryl amines, okay, alkyl, even aryl amines with benzene connected to NH2 or aniline, 1 degree amine, always prefer 1 degree amines. On reaction with halogen, sorry, bromine and NaOH, oh no, incorrect. CHCl3 and NaOH. I forgot, I was writing the Hoffman bromide. I read Hoffman bromide, I was writing carbylamine, so that is why I got confused. CHCl3. So this will give CCl2 and this will produce RNC. Alkyl, and this will give you ARNC. Aryl isonitriles. These two are called as what? Carbyl amines, which are foul smelling in nature. That's the first reaction. Number 2 is the reaction of Hoffman bromide degradation. So again we have RC double bond O NH2. We call these amide as primary amide, 1 degree amide, because this reaction is very much suitable to create or to synthesize only 1 degree amines. So this will give you what? RNH2 along with Na2CO3, which is actually CO2 gas that with NaOH produces Na2CO3. So this is again the product will be 1 degree amine with 1 lesser carbon atom. That's why we call this reaction as Hoffman degradation. Hoffman bromide degradation. Why we are calling it degrade? Because 1 carbon atom is getting reduced. This is getting the degradation. These are the set of reactions which you already have done. This is a okay, one more product will be found, that is water. So H2O is here. So you can balance it accordingly, but if you don't balance it, don't need a problem, because it is just asking for the equations, not the balanced chemical equations. Let's have another question. Oh man, how many are left here? There's too many questions you have done already here. 4 mark question haven't even come. So 1 gram of a non-electrolyte, 1 gram, a non-electrolyte is solute is dissolved in 50 gram of benzene. Lowered this benzene boiling point by freezing point by this, that is zup 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 zup. Let's try first question. A. We will apply the formula that delta TF is equals to I into KF multiplied by molality. 1 gram of non-electrolyte vol is taken, 50 gram of benzene is there, lowered by 0.4. This is 0.4 equals to I. It's a non-electrolyte, so we'll put I as 1. KF is 5.12 into molality is given mass upon molar mass. Actually molar mass has to be calculated. Molar mass of solute into 1000 divided by the mass of benzene or the solvent, 50 gram. So this is what we have to solve, and we have to identify M of solute. M of solute will be what? This is what? 50, 20. So multiplying this by 20. So 5.12 into 20 by 0.4. 0.4 will make it what? 50. So 50 into this will be 256 gram per mole is the correct answer. 256 gram per mole. First option we have done it. Next comes significance of KH. So Henry's law constant has so many significances. Number one is higher is the value of KH, lesser will be or higher is the amount of pressure required to get it dissolved, or lesser is its solubility in the given solvent. So that is one of the significance. Other significance can be written down over here. Significance of KH is higher is the value of Henry's law constant at given pressure, lower is solubility. Okay, that is the significance. What leads to anoxia? That was another question. What leads to anoxia? So anoxia is, what is anoxia? Lesser dissolution of oxygen in our basically respiratory system, and due to which our body feel lack of senses, and more about like vomiting kind of thing happens. This is called as the anoxia. And usually whenever you go to higher altitude, you might have seen so many people getting sick because of this altitude sickness, and that is actually anoxia, which is nothing but the lesser extent of oxygen getting dissolved in your body and your blood, and that results into some sort of lack of the oxygen reaching to our tissues and uncomfortable vibes. Okay, that's it. So that was another question we just finished. Then comes a question came in 2019, a very important question. Says that which of the following is second degree? So second degree means is the one which is connected with two alkyl groups. So this is where we can explain all three. This is actually 1 degree, this is actually 2 degree, this is actually 3 degree. This is the correct answer, A. B is complete the following reaction. So how can we complete this reaction? If we have NO2 and some reducing agent is given, SnHCl, FeHCl, metal HCl, metal CH3COH, metal and acid have been given, they produce a H2 gas. H2 gas goes and reduces this NO2 into NH2 called as aniline. This aniline on reaction with CH3 CO whole twice O, which is called as acetic anhydride, under the presence of pyridine. Basically pyridine is absorbing HCl coming out of this as a product, and this is called as the acylation of aniline. This will give you NH, C double bond O, CH3. This is the product we are getting. So this is your A product, this is B product. If you face any doubt, do let me know in the comments itself. I'll help you to solve it. Sir, how to convert ethanamine into methanamine? And that is a good question, by the way. So there could be several ways to convert ethanamine into methanamine. One you can do, I'll explain it. Ethane to methane. Well, every reaction is not possible, dude. I wish I could have converted into carboxylic acid first. I don't think that's possible. Because I'm not getting any COH group there, no. I could have done it carboxylation, decarboxylation, but not getting any product as such. There could be several steps involved in it, but yeah, that's why, not so useful I can find, because there's a plenty of steps involved, not a direct reaction as I see, and not even 1 or 2 step, it's a multiple step involved. Okay, you can convert it anyhow, but it's not so easy to convert it down. You try solving this question, guys. This is a repeated question from 2022 and 2017. I can read your chat also, not a problem. Let me know what you want. Oh, ha. I was also planning the same. Please do it. As I told you, it won't occur in a single step. It will take a lots of reactions to take place. Okay. So once I complete this all, I can take a half an hour ask me anything session. There you can ask me anything you want. I'll do it. Okay. But I don't want to disturb the ongoing momentum. Otherwise, I will not be able to solve all the questions. Finishing all of them on time. Okay. Transition elements show variable oxidation state because of the NS and N-1D a low energy gap. Because of this lower energy gap, both electrons can be excited and variable oxidation state can be shown. Number one, how Cu2 plus to Cu copper is positive? We have already done it. We already have done it. I think that their energy which is required for atomization, enthalpy of atomization and enthalpy of ionization dominates over the hydration enthalpy. That means Cu more stable than Cu2 positive and doesn't go easily with Cu2 positive. Cr2 positive is a strong reducing agent, which is also true because as I told you, Cr2 plus has a configuration of 3d4 4s0. After removing one electron or undergoing oxidation, Cr becomes Cr3 plus, which is 3d3 4s0, and this happens in aqueous state, and this is a half filled, it's a half filled T2G configuration which is stable. Every reason over there is written over here, guys. You can check it out. Transition element, why shows a variable oxidation state? Because of the similar or like a very lesser energy gap between N-1D and NS, which can show NS, and because transition metal have N-1D empty orbitals are closer to outermost NS orbital. Then why is this is very much positive? I have already explained. And why this is it? Because it has a half filled electronic configuration of T2G. And now finally we have come. Sir, why F orbitals are called inner transition? Beta, I'll give you a time. I'll give you ask me anything time, beta. Please let me go in the flow itself. Na? Otherwise, we'll not be able to crack it. Because they all F block lie inside the transition elements. Na? Inside the transition, right after lanthanum, right after actinium. Whole between the transition, we call them inner transition, between the transition. Okay, let's come to 4-mark question, and which are case based question. So I think mainly of you would like to take participation over here. Come guys, let's start it. Please read it out. That's the first case we are having, and right after the case study I will also take you to some questions. Okay, or even if you are not able to read it out properly, you can do it by your own. You can take time. This is it's already been appeared in 2021. One of the important question is here, and in this question so many things are happening here, and we have to identify. Okay, so let me read it. A class of organic molecule contains a carbon atom connected to an oxygen atom by double bond is called as an aldehyde, and ketone is called as carbonyl group. Aldehyde blah 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 blah. यार कौन पढ़ेगा यार, पढ़ना ही पड़ेगा दोस्त. Aldehydes are prepared by the oxidation of alcohol. Formaldehyde is sold in an aqueous solution called as formalin, and propanone, simplest ketone, is commercially sold by fermenting corn or oxidation of propane to all. Carboxylic acid also have carbonyl carbon. They can prepare the oxidation of alcohol and aldehyde. Formic acid was first isolated by distillation of red ends, and distillation of red ends because formic acid is actually derived from formica are the red ends, and it's partially responsible for the pain and irritation with actually wasp stings. Whenever we get stung by the ants, then we feel this kind of irritation. And the aldehyde with hydrogen undergo aldol condensation, alpha hydrogen basically, and the aldehyde without hydrogen they undergo Cannizzaro, and ketones are highly reactive. Then ketones are highly reactive although less than aldehydes, and ketones are obtained by oxidation of secondary alcohol. Ketone possessing the hydrogen undergo aldol condensation. Carboxylic acid occur widely in nature and are used in. So anyways, this is something, a paragraph upon aldehyde, ketone and carboxylic acid in front of you everyone. Hopefully you all have read it. Now let me directly take you to the questions. The very first question has been asked in A, B, C, D like this. So we'll see how can we react to this question. So one of the question is, which of the following compound will undergo aldol condensation? Anyone that has alpha hydrogen. Does it contain any alpha hydrogen? No alpha hydrogen is there, it will not undergo. Benzaldehyde, another example that has no alpha hydrogen, will not undergo aldol. Ethanol, CH3, C double bond OH, this is alpha, so alpha hydrogens are 3, this will undergo aldol condensation. Next is write the chemical test to distinguish between propanol and propanone. Propanol and propanone. Propanol and propanone. So guys, this is called as propanone, which reacts with I2 and NaOH and giving CHI3 with CH3 CO negative O plus. So this is yellow PPT. While the other compound, which is called as propanol, so propanol has no reaction with I2 and NaOH. C, write the reagent required for this. So actually we require a mild oxidizing agent and selective one. Selective, why I am calling selective? So that it doesn't harm the double bond, it only oxidizes this, and also up to CHO. And the correct answer is actually PCC and MnO2. PCC, MnO2. Check out the correct answer, MnO2, PCC, pyridinium chlorochromate. Doesn't impact the double bond, only impacts the alcoholic group. Man, let's have another question of the same. D question, fourth question says an alcohol on oxidation gives compound B, and so no doubt this compound B is primary only, because B gives a negative Tollens test. That means it is okay, it's a secondary alcohol then, because CH3 CHOH CH3 on oxidation gives you CH3 COCH3, which doesn't give you Tollens test. This is a compound B, this is a compound A, but it reacts with hydrogen to compound C. If you reacted with N2H4 in basic medium, no, it reacts with hydrogen to compound C only. Okay, if it only reacts with hydrogen, then hydrazone will be the product. If it reacts only with NH2 and NH2, then this will give you CH3 CCH3 double bond N NH2. This is called as hydrazone. This is compound C. Now B reacts with NaOH and I2. Yes, we also know that this compound can react. This compound can react with NaOH and I2 and will give you CH3 CO negative plus CHI3, which is a yellow PPT. So identify A, B, C, D. You can see A, B, C, and this is yellow PPT of D. This is actually D. So now you get everything. You got everything. Okay, first is done. Let's see the rest of the two. Which of the chemical reactions, Clemmensen reduction and HVZ? Clemmensen reduction. Clemmensen is actually amalgamated zinc and concentrated HCl with aldehyde and ketone produces alkane. Check out, guys. Clemmensen reduction is over there, and this reaction is called as Hell-Volhard-Zelinsky reaction. Hell-Volhard-Zelinsky reaction. Beta halo acid. So alpha bromo, alpha. This is the CH carbon. This is alpha bromo acid. So reagent, you should remember what reagents have been used here. So guys, that was our actually first paragraph in the case study question, case based question. We had first question. Now we have the next question. Sir, how can we convert ethanol to butadiene? Beta, please allow me, please pardon me, allow me. I will explain everything, but now let me finish this whole concept first of all, rather than wasting time. Let's come to the another case, guys. Case number 2, question number 2 we have. Haloalkanes are organic compound where halogens could be chlorine, bromine, iodine or fluorine and are bonded to alkyl group, and these commonly compound undergo a variety of reactions including nucleophilic substitution and elimination reactions. One of the most common reaction is called as nucleophilic substitution reaction, and it is conversion of alkyl halide into an alcohol in the presence of strong base such as sodium hydroxide. For an example, if the reaction of methyl chloride in aqueous solution NaOH takes place, the Cl- is replaced by hydroxyl OH- group, resulting in the formation of the methyl alcohol CH3OH. The mechanism substitution of this reaction could be SN or SN2 depending upon the structure of haloalkane. We'll directly go to the question, guys, rather than wasting the time. Let's see the first question. In the reaction, chloroethane with alcoholic KOH, product formed is what? So alcoholic KOH is actually what? Strong base. It does what? E2 elimination, E2 reaction. Correct answer should be what? Ethene, B. Next, the reaction of chloroethane with alcoholic KOH is an example of alcoholic KOH is elimination reaction, E2 elimination, D. Next, the E2 elimination is characterized by formation of carbocation. No, it's a one-step considered mechanism in which simultaneous abstraction of proton and departure of iodine take place. B is absolutely correct. The major product of elimination reaction of chloroethane with KOH is determined by the elimination reaction of chloroethane of KOH is determined by the stability of the carbocation. No, carbocation is not formed. The amount of base used, the formation of the most substituted alkene. Correct, C. The nature of the solvent. The major product of the elimination is decided by the formation of the most stable substituted alkene, because there could be Hoffman alkene product used, Sedzeff alkene also. Sedzeff is major product, Hoffman is a minor product. Try the next question. Shaurya Srivastav, don't panic, dude. I am right now over here I've been teaching from past 4 hours consistently. I might have got exhausted. I might have not responded back to you, but don't be sorry. Please wait up to the end of the session. We have plenty. We already have completed over 50-60 questions. We just have a few questions left. And right after that, I'll take one proper session of doubts only for half an hour, where you, along with your friends, whatever the question comes in your mind, just shoot your question. I'll totally accept the question. Don't worry, okay? No need to be sorry. Let's come to another paragraph, we have paragraph on electrochemical cell, which consists of two metallic electrode dipping in the electrolytic solution. This electrochemical cells are two type: galvanic, in which chemical energy is converted into redox reaction, which is chemical energy of spontaneous reaction is converted into electrical work. Whereas in electrolytic cell, we require an electrical energy that is carried out to carry out a non-spontaneous reaction. The standard electrode potentials for any of the electrode dipping in the appropriate solution is defined with respect to the standard electrode potential of the hydrogen electrode taken as 0. So we have She is taken as 0. Let's see their question. Number 1 question, depict the galvanic cell. Whenever it says depict, that means it is asking us to write down the cell reaction or like cell representation. So cell can be represented as zinc from solid converting into Zn2 plus, aqueous, then we have salt bridge where Ag plus from aqueous state. Since no concentration is giving, I am directly writing them. This is the cell representation. This is actually, it was asking us for cell representation. Number 1 question. It's HOTS 2021 high order thinking question. B, what happens if the external potential is applied to greater? Guys, if E external is greater than E cell, in that way the reaction becomes opposite, and this becomes from galvanic cell to electrolytic cell. From electrolyte it becomes what? From electrochemical cell or galvanic cell it becomes electrolytic cell. Fine. So the answer has been also given over here, that if an external potential is applied to an electrochemical cell, it becomes greater than the cell potential. The chemical reaction within the cell will reverse, and the cause of the cell to behave like the electrolytic cell, meaning it will now use the electricity to derive the non-spontaneous chemical reaction, that is the opposite reaction. Okay, so basically let us suppose a reaction is carrying out here as zinc plus copper sulfate is forming zinc sulfate plus copper. This cell has some value of, let's say we call it E0 cell. Now we are applying an opposite potential to the cell so that the reaction reverses itself, and the reaction becomes what? That now copper will react with zinc sulfate, where copper sulfate will be formed and zinc will be deposited, and when it is having, when E external is higher than the cell potential, when E external is even more than the E0 cell, then it becomes like a, this is already a galvanic cell. Now once the reaction is reversed, it has become electrolytic cell. Let's see another question. How do conductivity and molar conductivity vary with concentration? Another important question, by the way. So guys, we have conductivity first. Kappa. It is defined as the conduction offered by 1 ml oblique cubic centimeter solution. So with increasing dilution, kappa decreases because the number of ions per unit volume will be decreased. Now if you talk about the molar conductance or molar conductivity, both of them are the same only. Conductance and conductivity are different, but molar conductance and molar conductivity lambda is always the same. So this is defined as the conductance offered by 1 mole of electrolyte rather than the volume, let it be any volume. So with dilution, if we do the dilution, increase the water, with dilution degree of dissociation of the electrolyte alpha increases and more number of ions will be produced, and so does the lambda m increases. So that's it guys. You can also write it in even better way, as I am feeling a bit exhausted, might have not given the lengthier answer, but this is also absolutely fine. It's a 1 mark question only, by the way. Let's see the another question, D question. Calculate the delta G of the reaction. So I'll help you to find it out. You can calculate it by your own. Simply we'll find out this as delta G naught is equals to negative of NF E naught cell. How many electrons are transferred? 2 electron, 2 into 96500. E naught cell is 1.56. Please solve this equation and you will be getting your answers in joule. That's the first question. So it's one more question is given in or as a choice, that calculate the aim of the cell at 25 degrees Celsius. So we have to find out E cell. So first of all you need to write down the equation. Equation is already there. Just apply the E cell is equals to E naught cell minus 0.059 or 0.06 divided by number of electron transferred is 2, logarithm of product we have Zn2 plus, so we'll simply write it 0.1 divided by, we have 2 Ag, so 0.01 raised to power 2, 0.01 raised to power 2. This is 10 to the power minus 4, this is 10 to the power minus 1. This will become 10 to the power 3 in positive. So this will be coming up as 3. So 1.56 minus 0.03 into 3. So 1.56 minus 0.09 will become 1.47 volts. Correct answer. Already you've got both the answers. Let's move forward. So guys, this is the final part of today's session. Just allow me a 5-minute break. I'll be coming back. I'll be joining you back in just 5 minutes, okay? That's it, guys. We can't take any more break from here. Otherwise, the time is very precious, guys. Please understand those who are right now watching me. The only thing you can do to cheer me, just like the session, dude, and that is enough. I have had enough compliment. Thank you. So guys, come back and let's have the final round over here, which is the most important, most weightage carrying part over here. This is your 5 marks question. So in your session, I guess 3 questions come of 5 marks. Let me check how many questions from 5 marks come. There it is. So there will be like 3 questions of 5 marks which will be coming in your exam. So out of these 3 questions, I would like to explain you some 5 to 6 questions I'll take today, so that you will be getting enough of the time on these questions. So guys, always think in this way that these are the questions which require around 100 plus words to write. So let's say if you are writing in your writing font is a bigger, it must take 1 to 1.5 page, and if you write it very small font, then it should be like 3/4 page must be covered in 5 hours. Okay, I think 1 page should be covered. This is what we plan. Around 100 25 150 words you can go up to. This is your 5 marks question, and always save your time. Always save your time. I keep on saying this, that always save your time for these questions. Otherwise, what will happen? This is the game where you can score 15 marks for very easily, and writing so much of the things, and instead of wasting your time in just 1 or 2 mark question, if you even don't know, just skip them as of while. Okay, let's see. It's a 5 mark question, guys. The first 5 mark question over here. However, this is an easy question because this simply requires the identification of these groups. So I'll help you what your products could be. So guys, this is your benzene with nitro group. So nitrobenzene is given to us, that undergoes a reaction with SnHCl. Whenever SnHCl, FeHCl, NaHCl, these kind of things have been given, it's a reducing agent, and it reduces the nitro group to NH2 group, making it aniline. This is your compound A. Then this compound is further made to react with the acylation. Another reaction is also going in the sidewise, where you are bringing this reaction of H2SO4. So first of all, it will make a salt like this, because it's a base and there is an acid. So it will become NH3 plus HSO4 negative. This is called as aluminium sulfate, aluminium bisulfate. This kind of salt will be formed, which upon further heating produces sulfo compounds, which is NH3 over here, NH2 group over here, and there will have SO3H. So this is the first product which we have got as BE. This is the E product, this is A. Now let me continue the reaction. So this is about to made with the acylation. This has been undergoing acylation. CO whole twice O under pyridine. HCl will be eliminated out, and this compound will be converted into amide group, NHCO CH3. This is your B compound. This B compound is allowed to react with HNO3 and H2SO4. Otherwise, the product which you have got were different. Very different products would have been received. This is nitration which we are doing. So ortho and para substituted nitric product will be there. NHCOCH3. Let's say there I have added a nitro group. This finally will undergo reaction with acidic or basic condition to regain you this compound of aniline with nitro at the substitution. This is your D compound. Now this is your C compound. This is B compound. There you can get A, B, C, D all. So by the way, if you want to obtain all 5 marks, my suggestion will be better you write individual steps. Try to complete the whole page, because this is what sometimes an examiner or a teacher likes, that okay, something is being mentioned very specifically and line by line. Okay, each line can contain 1 mark, and he will be giving you full 5 marks in that. Okay, chalo. First question from 5 marks is done now. All got it? Well, let's see the another question from 5 mark. So this has been given in 2 ways. The one is a compound along with so many reactions, another one with this. So let's say I am doing a question, but guys, please let's understand this part, that I might be writing the reactions very casually and very clearly, but yes, you have to mark every single reaction, also mention their names, because as I'm running out of time also and I'm running out of space also, I'm not writing it, but you will be given with the extra sheet also. And you can ask ma'am sheet, search sheet, and you can fill your sheet accordingly. So we have an organic compound C6H7. Definitely it is containing, definitely it contains a benzene group in it, C6H6, and rest CHO group will be this. See. So basically what we are giving is benzaldehyde. This is our C7H6O. then this forms a 2,4-DNP derivative. That means it contains an aldehydic or ketonic group, and also reduces tolerance reagent and undergoes a reaction Cannizzaro also. On oxidation, it gives you a benzoic compound, and on oxidation, it gives us a benzoic acid only. So what is the compound, and also what are the reactions involved? So this is your compound which you are getting as an oxidation. You can also write some of the reactions given over here. Number 1 reaction is CHO on reaction with 2,4-DNP, 2,4-dinitrophenylhydrazine. So this will give you a product like this, phenylhydrazone. This is the final product. Number 1 reaction involved. Number 2 reaction with tolerance reagent, which is ammonical silver nitrate. So the reaction product will be CO negative. It will be oxidized, while the silver will be precipitated as this, and rest ammonia will be eliminated out. Ammonia gas will be released, or NH3OH, NH4OH also. In that way it can remain over there. So number 3 reaction is on Cannizzaro reaction. To mention its Cannizzaro reaction, Cannizzaro reaction takes place in concentrated NaOH, where subsequently 2 equivalent will be used. One of them will be oxidized, another one will be reduced. That's all the reactions are. Mention them properly, their test with DNP test, Tolan test, and then write with reaction with like Cannizzaro reaction of benzaldehyde. This is how you have to explain every part. Then you will be getting full out of full marks. Next is their identification. Identification between what? Phenol and propanol. Propanol. Okay, CH2H. This is propanol and this is phenol. So this is more acidic. So if I react it with NaOH, then ONA plus half hydrogen will be released. One hydrogen will be released instead. We react with NaOH, no reaction. There is one test that you can do. The another test could be or let me just write it, or reaction with bromine water. So that will give a this yellow white PPT for white PPT of 2,4,6 triabromo product, or the another one will not give any reaction as such. Then is benzoic acid and benzene. So benzoic acid is there, reacts with sodium bicarbonate and gives you CONA H2 plus CO. This gives you bicarbonate test positive. This is what we gives bicarbonate test positive, but the another compound which is benzene on reaction with same reagent, no reaction. So this is how we can identify. This is the test of identification of these two compounds done, and different reactions under this segment done. Complete 5 marks will be getting. Yes, if you write it properly, if you write it exactly like me, definitely 4.5 will be given to you. I know I might not be writing very clearly and neatly over here because it's been 4 hours. I've been feeling tired now, but still, if you can do it, guys, there's a 3-hour test you'll be giving. I have solved more than 70 questions of today. More than 70 questions we have done it for the day. 50-60 question aaram se. Let's see another question, and you will be facing only 33 questions in the exam, so you can do it. Let's see the third important question. This is an 2019 asked question. ABC has to be determined. I'll make it by you for you. So this is a strong oxidizing agent. Strong oxidizing agent will be converting into CH3 COH. This is A. This will make CH3 C double bond O COCl. COCl, OH group will be eliminated out, and this will become CH3 COCl. Acid halide. NH3 will be attacked there. NH3 will be attacking and forming an amide CH3CONH2. And NaOBr, this reaction is called as Hofmann bromide degradation reaction. The final product will be CH3NH2. This is the final product. Amine, 1 degree amine. So that is how you can do it. Just try to do right individual steps according, so that step marking can be there and they will give you more. Okay. Sir, is this a live session, recorded session? Why do you want to know, Nitish Kumar? Of course, it's a live session. Let's see the another question of this, another part of this question. So increasing order of their acidic character, which is very simple to identify. So what I'll be doing, CF3 will definitely be having highest stabilization of its conjugate ion, and this is how you can write it. And I make sure that this is how, if you write it like this, which I'm showing to you, you will be getting 100% marks. No, 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 no. If it would not have been a chlorine over here, formic acid would become better acid than rest of them. But yes, now chloro substituted acetic acid is more acidic. And then how would you show it? This is how you have to show that, sir. It will be giving you CH3CO negative. It will be giving you CCl3 CO negative, ClCH2 CO negative, and HCO negative. This is the order of stability. If this is the order of stability, then this will become an order of acidic strength Ka. The correct answer is this. This is how you have to explain it. That acidic strength is directly proportional to the stability of conjugate base or conjugate anion formed. Higher is the stability of conjugate anion, the reaction will take place to get into forward direction rather than coming back to the acid. Like that you have to explain it also, na? Right, very easy question here. So next 5 mark question, I'll bring it over here. This was another 3+2 type of question was there. You all have got it. Now another 3+2 type of mark question is here. So let's solve it. We have been given over here. We have to find out the EMF. I'll do it for you. First of all, we have to write down everything very neatly. First of all, you need to write down the equation. What's happening? Al converting into L3 plus Cu2 plus going to Cu. So the equation becomes Al plus Cu2 plus. We have to balance this reaction also. It will become Al3 plus. It will become simply Cu. Now you have to multiply this by 3. Then you have to multiply by 2. You have to multiply it here by 2. That will multiply by 3. So that number of electrons are same. 2 plus 2 into 3, 6 plus is there. 2 into 3 plus 6 is there. So 6 plus 6 plus is like the LHS equals to RHS. Now using this equation, you have got to know that the number of electron transferred is 6. This is from 0 to 3 plus, and 2 atoms are there. 6 electrons are lost, 6 electrons are gained. So n is 6 now. Now you apply that equation, that E of cell is equals to E naught of cell, which is 2 minus 0.059 upon number of electron transferred logarithm of concentration of Al3 plus, which is 10 to the power 1 raised to power 2 upon 10 to the power minus 2, copper concentration minus 2 raised to the power 3. So this is 6, this is 2, 4 will come up. So 2 minus 0.01 into 4. Logarithm of 10 to the power 4 is 4. So this will become 1.96 volts. This is the first question answer we have got, applying Nernst equation. Okay, you can also mention this part like applying Nernst equation, so that it will be very much impactful. Next is define molar conductivity. The conductance which is offered by 1 mole of any substance, irrespective of the volume taken for a solution, is called as its molar conductivity. Defined by and designated by lambda. You have to clearly mention it, lambda m. On dilution, it increases because okay, it increases. And why does it happen drastically? You can explain this thing by making a proper diagram also. So there is one graph like this, there is another graph like this. So guys, this is a graph for CH3CO negative Na plus lambda naught lambda, and this is a graph for lambda of CH3COH. They are HCOH or CH3COH. Okay, H. HCONA, and this will be HCOH. This is lambda and this is root of concentration, molarity. This is how you can explain it properly, that in case of weak electrolyte formic acid, initially there is no too much of the dissociation of the molecule, and a lesser number of ions were available. The conductivity was increasing very slightly, but once it reaches towards the zero concentration or very high dilution has been done over there, then the reactivity, molar conductivity abruptly increases and becomes perpendicular to x-axis or parallel to y-axis, and we cannot find out the limiting molar conductance at infinite dilution for this weak. Like in for strong, the variation is quite linear. By extrapolating the curve, we can also find out the value of lambda naught m, which is called as limiting molar conductance. So just mention it one by one, easily you can do it, I think so. And that's it, we have completed this. Let's have the another question. This is your next question, and find the order with respect to x and y, rate law, and everything you can do. Try to, first of all, solution, try to make the equations in this way, that these are the experiment, and write all the equations first of all. Okay, we'll write it like this. See, initial rate is 0.05 is equals to rate constant into 0.1 raised to the power small x, in terms of x we are taking, and 0.2 as of small y. The order of reaction with respect to x, let it be small x, and with respect to y, let it be small y. You have to write it like that. So if I divide this equation by 0.10 is equals to k into 0.2 to the power x and 0.2 to the power y, see, this will be cut down. This will be like 2 is equals to 2 to the power x, so x comes up as 1. This is how we got the value of x. Now similarly we can apply the same equation once again for, let's say, these we have already done it for this first and third. We can apply first and third. So this will be 0.05 by 0.05 is equals to k 0.1 raised to the power x and 0.2 raised to the power y divided by k into 0.1 raised to the power x and 0.2 raised to the power y, 0.1 raised to the power y. If you solve it, you will find out that k will be cancelled out, that 2 raised to the power y is equals to 1, so y should be equals to 0. So this is how we have already got the final answer. We have got the order first, we have got the rate law. Rate law can be written down as k into x raised to the power, consideration of x raised to the power 1, y raised to the power 0, and y rate, the final rate constant k will be what? So pick any of the things and you can identify it. So 0.05 is equals to 0.1 k into 0.1 raised to power 1, 0.2 raised to power 0. This is 1 only, so k will be coming up as 5 into 10 to the power minus 1, or 0.5 is the value of rate constant order, and the unit will be second inverse. So this is everything you can do just using the things, and this is the most repeated question of the day. That's why I have come up with this. Now guys, I'm announcing the session is over now. You better try questions from your end. This is some question you can take as a homework. Let's take another question as another homework. Okay, so please do it, and if any of the things you cannot do by your own, just let me know. Please do them as a homework. You can get every single question. If you Google it, you will definitely get the answer. If not, then let me know. Guys, on the very first page I gave you, let's suppose if you are not able to solve any kind of question, please reach out to me. I am always eagerly waiting for you all. Just scan this and stay connected with me. I am your chemistry expert Sanjay Arya sir. Just scan it. This is Chemistry Wizard, and you can get into touch with Chemistry Wizard. Okay, now you can ask me anything you need. If you want to ask me anything, please ask me. Some of you were asking me question meanwhile of the explanation, and I basically ditched you by that time, saying that I can help you at the end of the session, not exactly right now. So please ask me any of the question you are right now facing any doubt. Let me just write it here. You can ask me anything now. हाँ जस्ट तुम ये बता. हाँ हाँ वो ना बता. Yeah guys, so somebody asked me, sir, is there anything? What is the meaning of is there anything? Some of you were asking me by that time. Some of you were asking me some questions by that time. Now you can ask your doubts. You can ask me your doubts right now. Sir, who is talking to you? Actually, I received some call. I got some call by that time. I told you once the lecture will be over, let it be an official or unofficial question, let it be an academic or non-academic question, I'll definitely be answering to you. So that's why I'm giving you the answer. I hope John Peter, you might have got your answer. SP, got your answer. Nitish, got your answer. Who else wants to ask me? Ashish Sharma is asking me, sir, English कैसे सीखे आपने? I got it eventually. If you push yourself more into English, you will one day become very comfortable in English, like me. Any else, guys? Somebody asked me by that time, how can we convert methylamine to ethylamine? So guys, no, sorry, ethyl to methyl. If you want to reduce one number of carbon, we have to reach anyhow to amide. Then an amide can be converted back to amine by Hoffman bromide degradation reaction. So ethylamine needs to be first converted into amide. Sir, for English class will be there. No, beta. This is the Unacademy JE channel. We do not have English faculties with us. I told you that time. So you can basically undergo diazotization reaction, which doesn't happen in the aliphatic amines. It directly takes you to formation of alcohol. That alcohol you formed will be ethanol. You can further oxidize, forming as CH3COH, which upon a treatment with ammonia and heat can give you amide, which upon bromamide, bromide will give you what? Methenamine. But I told you it's not a direct process, it's a long process, will take you so many steps actually. Sir, for math, yes, for maths there will be a session, guys. So for math, a session is about to come. Hopefully, you all have enjoyed the session. I also have enjoyed with you. Thank you so much, everyone, for being over here. Now you can like the session because right now I'm about to leave. It's been a pleasant serving you all. Bye bye, guys. Take care and miss you all. Okay, sir. Can you please teach CFT right now? You want to don't worry, Mr. Buddha. Mr. Buddha, I have already explained this crystal field theory in one of my previous lecture called as this lecture name was uh, coordination compound. Please find the live segment in this channel only, which is your Unacademy J English. In live, you will go and you will find coordination compound chapter. There is I have explained CFT very well in very depth. Please visit that. Thank you. I think that's it, guys, for the day. So bye bye, guys. Take care, and we'll connect back soon. Okay, we'll connect back soon in next videos.